Every grain of sand on every beach on Earth could be outnumbered by the stars that watch us sleep. And yet the closest world we imagine living on is an arid whisper of a planet, painted red with rust and silence. Imagine standing at the edge of a cold crater, feeling a small sunspill light across a fragile horizon, and realizing that vast machinery and human hope must shoulder the work of every breath you take. Tonight we will walk that paradox slowly, tracing the science beneath the dream, the thin air, the hungry cold, the invisible radiation, and ask a quiet, unsettling question: what if Mars is not a second home, but a lesson we cannot afford to forget? Like and subscribe if this drift between wonder and rigor feels like your kind of night, gently, and join our small constellation of listeners. Come with me on a slow, close, and honest voyage to the red world. Let's begin. From a distance, Mars glows like a dying ember, beautiful, distant, promising warmth. But that crimson glow is a mirage. The red we see isn't life, it's rust, iron oxide dust coating an entire planet frozen in time. To dream of home here is to mistake colour for comfort. If you could stand there, beneath its pale sky, in the thin whisper of its air, you'd find a silence unlike any on Earth. Every horizon looks painted in fire, yet the warmth you imagine never arrives. The dust is everywhere, a fine, choking powder that drifts endlessly, covering rock and metal alike. Each particle is sharp, electrostatically charged, and ancient, ground from mountains older than life itself. Even in stillness, it moves. Mars is always shifting, breathing softly through storms that never rest. The redness is a relic of oxidation, a slow chemical whisper that turned iron into rust over billions of years. Once, long ago, water may have flowed across this world, carving canyons and valleys, leaving behind traces of rivers that gleamed under a younger sun. But the water vanished, boiled away by time, and lost to space, and what remained was dust, iron reacting with oxygen, staining the planet forever. That same rust now reflects the sunlight in warm tones that deceive our eyes, making Mars look alive when it is anything but. If you held that dust in your hand, it would feel like ash from an ancient fire. Yet it burns nothing. It carries no heat, no scent of life. The illusion is purely visual, a trick of chemistry and light. We see beauty and think of deserts at sunset, of warmth and survival. The desert never ends, and the air itself could not keep a candle lit. Orbiters and rovers have revealed what the eye cannot see. Beneath the red, the land is grey, basaltic, volcanic. The planet's surface tells a story of eruptions and impacts, of a world once active and now dormant. There are plains where lava once flowed like rivers, frozen mid-motion for eternity. Mountains taller than anything on Earth cast shadows across canyons so deep that entire clouds could hide within them. Yet even these wonders feel like ruins, remnants of a world that almost became something more. We call Mars the Red Planet, but that title hides a quiet sorrow. Its colour once came from vitality, minerals reacting in water, chemistry alive with possibility. Now it's the residue of loss. The same oxidation that gave the planet its beauty also testifies to its desolation. The red is not the colour of life beginning, it's the colour of life that never was. Still, the human mind clings to the image. The glow of Mars in our night sky feels intimate, almost reachable. It's easy to imagine warmth in that light, to think of campfires, sunsets, home. But Mars is a mirror that reflects our longing more than our destiny. It looks alive because we wish it to be. It shines because we need it to. And in that fragile illusion, in that red mirage, we see the oldest truth of all, that even in the emptiest corners of the universe, we search for something that feels like home. The Martian air is whisper thin, barely 1% of Earth's. You could fill your lungs there, but nothing would come of it. The air would offer no oxygen, no relief, only silence pressing inward. an invisible vacuum disguised as atmosphere. On Earth, we move through air so effortlessly that we forget it has weight. But on Mars, that invisible ocean is gone. The sky may look familiar, faintly tinted by dust, yet what surrounds you there is almost nothing. Each breath would be futile, a hollow gesture against physics itself. The pressure is so low that exposed water doesn't boil or freeze, it simply vanishes, sublimating into the void. Step outside without a suit, and the difference between life and death is measured in seconds. The moisture in your mouth would flash away, your blood would begin to bubble, and your lungs, designed for Earth's embrace, would collapse inward. Mars does not kill violently, it kills through absence. It doesn't suffocate you with force, but with stillness. The composition of the Martian atmosphere is mostly carbon dioxide, 95% of it in fact. There's a whisper of nitrogen, a trace of argon, and almost no oxygen at all. Each molecule is thin, widely spaced, moving sluggishly in the cold. The sound itself travels differently here, muted, faint, as if the world were holding its breath. A human voice would sound strange and distant, stripped of warmth and tone, lost before it could echo. For engineers and scientists, this thin air presents a constant enemy. Parachutes barely work, there's not enough drag to slow descent. Aircraft struggle to lift, rockets must overperform, and even dust, so light, so fine, settles slowly, refusing to obey gravity in any familiar way. The Martian sky is both heavy and empty, a contradiction that makes every mission a battle against physics and patience. Imagine standing on a ridge as the pale sun sets. The horizon burns in muted oranges, the temperature falling fast. You look up, expecting the stars to pierce the twilight, but the air is too thin to scatter light, and the sky remains strangely flat, like glass. In that fragile stillness, you might hear the faint hiss of wind dragging dust across rock, a sound older than humanity itself. It would feel almost peaceful, if not for the knowledge that the air brushing against your visor could never fill your lungs. And yet, in this near vacuum, life once flirted with possibility. Billions of years ago, the air was thicker, wetter, warmer, rivers flowed freely, and storms rumbled across valleys filled with vapor. But as Mars cooled, its magnetic shield faded, and the sun stripped the atmosphere away molecule by molecule. What remains is a fossil of air, a fragile echo of what was once a living sky. To dream of colonizing Mars is to imagine reawakening that breath, rebuilding an atmosphere from scratch. It means capturing carbon dioxide, splitting it, creating oxygen molecule by molecule, a project that would take generations. For now, the planet waits in silence, its air too thin to carry even a whisper of life. And as you drift in thought, you realize Mars doesn't suffocate you out of cruelty. It simply reminds you of how miraculous breathing really is. On Earth, every inhale is a gift you never asked for. On Mars, you would understand its worth. On Mars, gravity is gentle, too gentle. Each step would feel light, almost freeing. Freedom here means decay. Bones weaken, muscles shrink, and hearts forget how to fight Earth's pull. A colonist's body would slowly unlearn how to live. At first, it might feel miraculous. You leap higher, walk farther, carry burdens with ease. A world where 100 kilograms feels like 30. Where movement is effortless, and your own body seems to float in defiance of the familiar. The body is an instrument built for Earth. Its bones are tuned to gravity's rhythm, its muscles forged under weight. Take that away, and the song starts to fade. In Martian gravity, just 38% of Earth's bones lose calcium faster than any exercise can replace it. Within weeks, density begins to drop. Legs thin, vertebrae compress, the spine elongates in strange ways. Astronauts who spend months in microgravity aboard the International Space Station experience similar losses despite constant training. On Mars, the same decline would never stop. Every step, though graceful, would be a negotiation between adaptation and decay. The heart, too, changes. Freed from Earth's demand to pump blood upward, it weakens, shrinking slightly in size and force. Circulation slows. The body, no longer challenged by its own weight, rewrites its chemistry for an easier world. The result is a paradox, a body that feels stronger but grows frailer, a physiology that evolves toward extinction. Even the sense of balance begins to slip away. The inner ear, attuned to Earth's gravity, sends unfamiliar signals to the brain. Movement feels slightly off, dreamlike. Walking in 1/3 gravity is like dancing in syrup, every step a little too slow, every fall too soft. Over time, the brain adapts, recalibrating itself to Mars's gentler pull. But adaptation comes at a cost, return to Earth. And that same brain will be confused again, unsure of how to stand, how to walk, how to belong. For long-term settlers, these changes wouldn't just be discomfort, they'd be irreversible evolution. Generations born under weaker gravity might never be able to return home. Their bones would be too fragile for Earth's weight, their organs too accustomed to ease. Humanity would begin to divide not by geography, but by gravity itself. Two species, one bound to Earth, the other to the red dust. And yet, in that thought lies a strange beauty. Mars, in its quiet indifference, would sculpt us into something new. The same planet that strips the air from our lungs and warmth from our skin would also shape our bones, our hearts, our very definition of life. Still, every gain would carry a quiet grief. A colonist looking up at the pale blue dot of Earth might wonder what gravity really meant, not just a force, but a feeling. The invisible hand that taught us to stand, to dance, to build, the force that shaped everything we've ever loved. On Mars, freedom would not mean flight. It would mean learning to live without weight and slowly forgetting what it felt like to fall. Night on Mars can fall to negative 120 degrees Celsius. The kind of cold that stops machinery, freezes fuel, and turns metal brittle. Even the sun, so small and pale in the sky, feels like a ghost of warmth long gone. There are no seasons of comfort here, only degrees of survival. When twilight descends, it doesn't bring peace, but a deep, creeping stillness. The kind of silence that only exists where heat has fled entirely. On Earth, cold is temporary, something that yields to morning. But on Mars, warmth is the exception, not the rule. Every sunrise is weak, distant, and brief. The planet's thin atmosphere cannot hold heat, and the energy that does arrive bleeds back into space almost as quickly as it came. Imagine standing on that frozen ground. The air, thin and sharp, carries no scent. Frost forms not just on metal but on dust itself, crystallizing the edges of every grain. Your breath, if you could see it, would fall like smoke made of glass, dissipating in seconds. The faint sunlight feels like winter seen through a veil. Shadows stretch endlessly, and the horizon glows in muted oranges that never quite reach your skin. The cold here isn't uniform, it moves like a living thing. At the equator, midday temperatures may tease survivability, rising just above freezing, yet a few hours later they plunge back into the abyss. Near the poles, carbon dioxide, the same gas that chokes the Martian air, condenses out of the atmosphere, falling as dry ice snow. In winter, entire regions are buried under this frozen gas, and when spring returns, it sublimates with a ghostly hiss, releasing plumes that whisper across the desert. For human machines, this endless cycle is a slow torment. Batteries lose capacity, lubricants congeal, and circuits shrink until they fracture. Rovers built with exquisite precision must endure nights longer and colder than anything they were designed for. Some never awaken after dusk. Their cameras glaze over, their joints stiffen, their processors fall silent beneath a crust of frost. Each new sunrise is a test of resilience, a heartbeat waiting to return. To survive such cold, humans would need habitats that mimic Earth's warmth perfectly. Heated walls, circulating fluids, power systems that never rest. Every watt of heat would be precious, every leak catastrophic. Yet beyond the hardship, there is a strange serenity in this frozen world. The silence is absolute. The air carries no rustle of leaves, no waves, no life. Only the occasional whisper of dust shifting over ice. It's a landscape sculpted by time and temperature, a planet that has perfected stillness. The cold on Mars is not just the absence of warmth. It is the presence of eternity. It has no malice, no mercy, only endurance. The same chill that freezes machines has preserved the planet's secrets for billions of years, riverbeds untouched, craters unweathered, fossils perhaps waiting beneath ice. And in that frozen desolation, there is a quiet truth. Warmth is not a constant of the universe. It is a fleeting kindness, a fragile coincidence. On Mars, the cold reminds us that comfort is rare, and that life, wherever it flickers, burns all the brighter for daring to exist against the dark. Every breath on Mars would be a death sentence. Carbon dioxide chokes 95% of the atmosphere. Oxygen is a trace, nitrogen a ghost. To breathe here is to borrow life from tanks that must never run empty. On Earth, the sky is an invisible cradle, soft, generous, alive with the rhythm of wind and rain. We inhale it without thought, never once questioning the quiet chemistry that keeps us alive. But on Mars, that same sky is a weapon of silence. Each molecule is an assassin of life, turning lungs into fragile vessels of panic. There is no oxygen to sustain, no nitrogen to balance, no ozone to shield. The very air is a toxin. Even inside a sealed habitat, the awareness never fades. Every hiss of an airlock, every whisper of a filter, is a reminder of the truth. Your next breath depends on machinery, and machinery can fail. You sleep to the hum of compressors. You wake to pressure gauges. You live in a house that must constantly make its own air, an island of atmosphere adrift in a vacuum. The poison itself is subtle. Carbon dioxide is invisible, odorless, patient. On Mars, it seeps into every crevice, seeking equilibrium. A single breach, a crack in the glass, a failed seal, and it will flow inward faster than the lungs can scream. The first signs are calm, dizziness, warmth, confusion, then stillness. Mars kills gently, as if it doesn't want to disturb the dust. The thin air holds another cruelty. Without oxygen, fire cannot burn. There are no flames on Mars, no candles, no hearths, no crackle of warmth. The human rituals of light and heat are impossible here. Even life itself, which burns oxygen at a cellular scale, cannot ignite without help. Every spark, every chemical reaction that defines existence, falters in this suffocating calm. Scientists have tried to imagine ways to change it, to breathe life into the red planet. Machines that pull carbon dioxide from the sky and split it, atom by atom, into carbon and oxygen. Tiny prototypes like Moxie on the Perseverance rover have already done it, transforming Martian air into a few grams of breathable gas. It's a technological whisper against an ocean of toxicity, but it proves something profound. Even in poison, there is potential. Still, the scale of the challenge is staggering. To create an Earth-like atmosphere, we would need to produce oxygen faster than it can escape into space. Mars has no magnetic shield to hold it, no gravity strong enough to keep it close. Every molecule we make will eventually drift away, lost to the solar wind. Breathing on Mars will never be natural. It will always be borrowed. And yet, in this impossibility, there is wonder. The same sky that kills us also paints sunsets of sapphire blue, scattered through dust that glows like firelight. From its surface, the stars seem closer, sharper, as if the universe itself leans nearer to listen. The poison may claim our air, but not our curiosity. Perhaps that is what Mars teaches, that breath is not guaranteed, that life is an act of rebellion against chemistry. We survive not because the universe welcomes us, but because we insist on breathing, even beneath a poisoned sky. Water exists on Mars, but only as ice or vapor, never comfortingly liquid. The moment it melts, it vanishes into thin air, lost to the vacuum. Even in the craters where frost hides, sunlight steals it away molecule by molecule. To find water is to find life, or the potential for it. On Earth, rivers carve continents, clouds cradle mountains, and oceans hum with endless creation. Every heartbeat, every cell, every breath depends on it. Yet on Mars, this sacred element is treated as an intruder. The planet itself rejects it, freezing or erasing every trace the moment it dares to flow. The Martian atmosphere is too thin to keep water in its liquid form. At these low pressures, ice doesn't melt, it sublimates, skipping the comfort of liquid entirely, leaping straight into vapor. When sunlight warms the surface, tiny pockets of frost shimmer briefly, then disappear like breath on glass. It's as if Mars inhales the very thing that once nourished it. Billions of years ago, this wasn't the case. The planet's valleys, canyons, and deltas tell the story of another era, one where lakes mirrored the dawn and rivers braided across plains of volcanic stone. The largest canyon, Valles Marineris, may once have carried torrents that carved through rock for thousands of kilometers. There were storms, clouds, and even shorelines. Mars was, for a moment in cosmic time, alive with liquid movement. Then, its magnetic field faded. The solar wind stripped its air away. With every gust of radiation, the pressure dropped, and the planet began to desiccate. Oceans became ice. Ice became vapor, and the vapor was swept into space, molecule by molecule, until Mars was left with nothing but the memory of flow. Today, what remains is locked beneath the surface, frozen in permafrost, or trapped deep within polar caps of dry ice and water ice layered together like ancient pages. Every now and then, orbiters catch glimpses of something hopeful, a dark streak down a crater wall, a patch of reflective ice exposed by a new impact. These recurring slope lineae once sparked dreams of flowing brine, but later studies revealed the truth. Even those were illusions, slides of dust and salt mistaken for water's graceful touch. The planet teases us with hints, but it never yields. For engineers and colonists, this is the most haunting irony. The element we rely on for everything, drinking, growing food, creating oxygen and fuel, exists here in abundance, yet it's locked away behind layers of temperature and pressure. To access it would mean melting permafrost in a world that cannot stay warm, collecting vapor in an atmosphere that cannot hold it. Even success would be fleeting. Water here is temporary by nature. And yet, Mars guards it carefully. Under the southern polar cap, radar hints at subglacial lakes, salty, dark, and ancient. If they exist, they might be the last refuge of something alive. Microbes clinging to existence in a realm of eternal cold. In those hidden depths, the planet's hostility softens for a moment, making space for the faintest echo of life's persistence. But on the surface, the war continues. The sun rises, frost glimmers, and before noon, it's gone, stolen by thin air and relentless radiation. Mars is a planet that has forgotten how to hold water, how to nurture, how to flow, and maybe that's what makes it so haunting. It is a reminder that the conditions for life are delicate, temporary, and easy to lose. When we look at the dry riverbeds of Mars, we are not just seeing the past of another world, we are seeing a possible future of our own. A warning written in dust, carved by water that once sang, and then was silenced. Mars sits farther from the sun, yet unprotected beneath a thin atmosphere. Sunlight strikes like radiation. It is both weak and lethal, a paradox of cosmic design. Light without warmth, heat without safety. When the sun rises on Mars, it feels distant, almost shy. The light filters through a sky tinted with rust, illuminating the world in shades of pale orange and rose. But the illusion of gentleness ends at the skin. The thin air offers no shield, no ozone layer to soften the blow, no magnetic field to turn away the invisible storm. Each photon arrives raw, unfiltered, carrying the bite of ultraviolet and cosmic radiation. To stand beneath that sun is to exist in contradiction. The light looks soft, almost peaceful, yet its touch corrodes slowly. It seeps through the atmosphere and strikes the surface with relentless precision. Human skin, unprotected, would redden and burn in minutes, not from heat, but from radiation slicing quietly through the cells. The sunlight feels weaker, cooler, yet it carries the kind of danger that cannot be felt until it's too late. Even machines suffer under its gaze. Solar panels that feed on light are slowly scarred by the same radiation that sustains them. Circuits degrade, coatings crack, sensors lose their clarity. The Martian day is long, nearly 24 hours, like ours, but each hour under that light is an experiment in endurance. Every rover that crawls across the dust carries the memory of sunlight as both savior and destroyer. At dusk, the paradox deepens. As the sun sinks, the sky transforms into something Earth has never known. Sunsets of blue and violet glowing at the horizon. It is not warmth that paints them, but scattering, the fine red dust bending the last light backward, making the setting sun shimmer in colours reversed. On Mars, sunset is not the closing of day, it is the final whisper of radiation fading into stillness. And then, darkness. The temperature plummets faster than reason allows. Without the cushion of a thick atmosphere, the planet cannot hold the heat it briefly gathered. The warmth drains away like breath into the vacuum, and the world becomes a frozen monument once more. Mars does not store light, it only borrows it for a moment. For future colonists, this duality will be one of the hardest lessons. Sunlight, which nourishes life on Earth, becomes something to fear. Each solar flare threatens power systems, habitats, and even DNA. Living on Mars would mean treating the sun not as a giver, but as a force to endure, installing radiation shelters, designing filtered windows, creating a rhythm of life that hides from the very light that sustains existence elsewhere. And yet, there is something profoundly humbling in this paradox. The same sun that nurtures us also reminds us of scale, of the fragility of habitability. A few million kilometers farther, and warmth turns to harm, a little less protection, and light becomes lethal. Mars, in its quiet way, reveals how narrow the line of comfort truly is. Its sunlight is a lesson written in photons, that life depends not just on light, but on balance, and that even the gentlest glow, if stripped of care, can burn the world it touches. Earth has a magnetic heart, Mars does not. Its once mighty magnetic field faded billions of years ago, leaving the planet naked beneath solar wind. Every second, radiation strips atoms from the sky. Every year, Mars becomes a little emptier. Invisible yet vital, a magnetic field is a planet's unseen armor. It hums quietly beneath our feet, born from molten metal spinning deep within a planetary core. On Earth, this magnetic dynamo turns our planet into a shielded sanctuary, deflecting solar particles, guiding compasses, and allowing our atmosphere to survive. Without it, sunlight would slowly peel away the air, molecule by molecule, until even oxygen could no longer linger. That is the fate that Mars could not escape. Once, long ago, its core churned with liquid iron and nickel, just like Earth's. But as the planet cooled, the motion slowed, and then it stopped. The dynamo that once generated its global magnetic field flickered and died. With that silence came vulnerability. The sun, beautiful from afar, merciless up close, began its slow work of erasure. The solar wind, a constant stream of charged particles, swept across the planet unopposed. It tore at the upper atmosphere, carrying away hydrogen from water vapor, oxygen from carbon dioxide, and nitrogen from the trace gases that once gave Mars its sky. Over billions of years, the air thinned, the pressure dropped, and what might once have been a habitable world became a desert of ghosts. Today, the remains of that shield exist only in fragments, patches of localized magnetism frozen into ancient rocks, scattered across the crust. Orbiters detect them like echoes of a song the planet once knew how to sing. These fossilized fields are weak, inconsistent, and unable to guard the sky. They are reminders that Mars was once alive with motion, once defended by an internal fire now long gone. Without that protection, radiation rains down freely. Cosmic rays and solar storms penetrate the atmosphere, bombarding the surface with energy that sterilizes soil and damages DNA. Any life that once flourished on the surface would have been driven underground, into caverns, beneath ice, or within rocks that could still hold the faint warmth of safety. If something living remains, it does so in hiding, like an ember that refuses to go out even after the hearth has gone cold. For future explorers, the absence of this shield is more than a challenge. It is a warning. Every habitat will need to mimic what Mars lost. Layers of shielding, magnetic fields generated by human hands, and shelter dug into stone. We would not just be visitors, we would be caretakers of our own artificial magnetospheres, rebuilding the very protection the planet forgot how to create. Yet, there is poetry in this loss. Mars reminds us that even worlds can grow old, that warmth fades, and motion becomes memory. Its silence beneath the solar wind is not just emptiness, it is testament to time's quiet power. As we gaze up from its surface, watching the auroras that flicker faintly across its thin sky, strange, patchy, and pale, we are witnessing the last remnants of a vanished shield, a faint glow that tells a story billions of years in the making, of a planet that once guarded its breath, and then, slowly, learned how to lose it. Beneath its scarlet dust lies a heart gone silent. The Martian core no longer churns with molten metal. It's cooled, fossilized, and with that stillness came the death of its dynamo, the invisible engine that once gave it life. A planet's core is its heartbeat. Deep within, under unimaginable pressure, molten iron and nickel swirl and convect, generating heat, movement, and magnetism. It's this inner dance that gives rise to a global magnetic field that protects an atmosphere that lets a planet breathe. Earth's heart still beats loudly. We feel it through earthquakes, volcanoes, and the shifting of continents. Billions of years ago, Mars was geologically alive. Volcanoes like Olympus Mons towered higher than any mountain in the solar system, built layer upon layer by eruptions that once poured molten rock across the plains. That activity was driven by internal heat, the same heat that kept its core fluid, dynamic and magnetic. But as the smaller planet cooled faster than Earth, that inner fire dimmed. The molten layers solidified. The convection slowed, then ceased. Its magnetic field flickered out. The moment the core went still, everything changed. The loss of magnetism meant exposure. The loss of heat meant stagnation. The planet's surface grew brittle and dry, its atmosphere stripped away by solar wind. What remained was a geologic relic, a world that had aged before its time, trapped forever in a state of arrested motion. Seismometers placed by landers like InSight have listened to that stillness. They've recorded faint tremors, echoes of a heart that hasn't completely died but barely stirs, a few weak quakes rippling through crust and mantle. They reveal that Mars's core is larger than once thought, but less dense, a mixture of iron and sulfur frozen into an imperfect sphere. It's not empty, but it's tired, a rusted relic rather than a burning forge. Without an active core, Mars lost more than its magnetism. It lost its geologic renewal. On Earth, molten movement recycles the crust, drives plate tectonics, and releases gases that replenish the atmosphere. Mars has none of this. Its crust is ancient and unbroken, a single rigid shell scarred by impacts and preserved by cold. Its volcanoes are monuments to a time when the world had warmth to give. Now, they stand silent beneath dust, their calderas filled with frost and shadow. If you could descend beneath the surface, down through layers of frozen rock and iron, you'd find no glowing rivers, no surging magma, only stone under pressure, heat fading into memory. It's strange to think of a planet as something that can die, yet Mars is proof that they can. Its cooling heart turned a living world into a mausoleum. And yet, there's a kind of poetry in its quiet endurance. The red planet doesn't rage against its fate, it simply endures, turning slowly under the same sun that once fed its flame. Its stillness is not failure, it is legacy. The iron at its core, oxidized and hardened, reflects the same rust that covers its face, the same dust that paints our skies red when storms blow strong enough to bridge the worlds. Mars no longer beats, but it remembers. Its core may be silent, but its story still pulses through every canyon and crater, a reminder that even when the heart stops burning, the memory of fire can still glow. Storms on Mars can cover the entire planet. Storms so vast they blot out the sun for months. Dust rises kilometers high, static crackling through the thin air. It looks gentle from orbit, but each grain cuts like glass. To live here is to live beneath a sky that never fully rests. From the first whisper of wind to the roar of a global tempest, Mars teaches the physics of patience and violence. The air is thin, barely thick enough to stir, yet what little atmosphere exists moves with unrelenting intent. Because there is so little moisture, there are no raindrops to weigh the dust down. Every gust lingers, every grain of rust-colored sand stays suspended, turning sunlight into haze and the horizon into a painting of shadows and ghosts. The Martian wind begins quietly. Tiny vortices form, dancing across the plains like phantom whirlpools of light. These dust devils twist and spiral hundreds of meters high, painting trails that can last for days. But sometimes, when sunlight heats the surface unevenly, they join together. The winds merge, strengthen, and grow, until what began as a whisper becomes a storm that swallows continents. Rovers like Spirit, Opportunity, and Curiosity have seen the onset of these tempests firsthand. The sky dims, then turns brown, then vanishes entirely. The sun fades to a faint disk, like a dying ember in an ocean of dust. Solar panels lose power. Cameras see nothing but a red haze. The air pressure drops, and the planet itself seems to disappear. During one such storm in 2018, Opportunity sent its last transmission. "My battery is low, and it's getting dark." The words became an elegy, not for a machine, but for a world that swallows even the light. From orbit, these storms are breathtaking. They appear as swirling ochre veils stretching from pole to pole, a planet wrapped in its own atmosphere. They can last for weeks, sometimes months. During that time, the temperature at the surface plummets. Sunlight, already weak, is blocked almost completely. Each particle of dust is microscopic, finer than talcum powder, sharp as volcanic ash. It is made of iron oxides, tiny, charged fragments that cling to everything they touch. It seeps into machinery, wears down seals, and coats every surface with a layer of red. To humans, it would be a quiet menace. Breathing it in would shred the lungs. Letting it settle on skin would burn through pores. On Mars, even dust is hostile. And yet, there is beauty in the chaos. When the storm finally breaks, sunlight returns like resurrection. The thin sky glows once more, the dust falling slowly, gently, across the plains. From a distance, it almost looks like snow. Craters shine, dunes ripple, and the planet exhales. The same forces that bury machines also sculpt mountains, polish stones, and spread iron across a world already colored by decay. Mars's storms are not random, they are memory. The energy that stirs them comes from heat still lingering from the planet's youth. Each storm is the echo of an ancient heartbeat, a whisper from the time when Mars still moved and breathed and burned. So the desert endures, restless and red. The winds keep carving, the dust keeps rising, and the planet keeps circling the sun as it always has. Mars reminds us that stillness is never truly still, that even in silence, the remnants of motion can move mountains and turn an entire world into a storm of light and loss. Mars is old, 4.5 billion years of stillness, carved by meteor impacts and winds that never stop. There are no rivers now, no forests, no sound but the whisper of dust. Time here doesn't flow, it accumulates. On Earth, time feels alive. It runs through rivers, grows in forests, and echoes in the rhythm of waves. It has texture, measured by seasons, shaped by life. But on Mars, time stands still. The same rocks that caught the first sunrise 4 billion years ago still lie scattered on the plains, untouched, unmoved, preserved by cold and silence. The wind shifts dust across their faces, carving faint grooves that take millennia to form. Here, change is not an event. Its erosion slowed to eternity. If you stood on the rim of an ancient crater and gazed across the horizon, you'd be looking into the past, literally. Each ridge, each boulder, each frozen dune is a page in the planet's memory. There are no forests to conceal it, no rain to wash it away. The scars of meteor strikes remain open wounds, perfectly outlined even after billions of years. Mars is a museum of its own history, its entire story written in rust and rock. Craters like Hellas and Argaea, deep enough to swallow mountains, mark the violence of creation. They were formed when the early solar system was still wild, when collisions between worlds were acts of growth. Those impacts shattered the crust, melted stone, and altered the planet forever. Yet, while Earth's surface has erased its past through tectonics and oceans, Mars remembers everything. Its skin is a fossil of time itself. The planet's winds are ancient sculptors. They trace the same patterns year after year, century after century. In some regions, dunes migrate only a few centimeters in a human lifetime. In others, dust devils redraw the landscape in minutes. But the overall picture never changes. The same features that early probes photographed decades ago remain exactly where they were, silent testaments to the patience of a dead world. Even the sky holds time differently. The faint light of the sun filters through air so thin that shadows seem sharper, longer, older. The days are almost Earth-like in length, but they feel stretched, each moment elongated by stillness. Nights last forever, the stars unblinking, the constellations frozen in place. Without an atmosphere thick enough to stir, even sound itself fades quicker here, leaving behind a kind of sonic emptiness that feels eternal. For scientists, this makes Mars a time capsule. It carries the geological record of a young solar system, the conditions that may have given rise to life, the processes that shaped Earth before we existed. Studying its rocks is like reading the first chapter of our own story, preserved perfectly in a vault of dust. Every rover that touches its surface becomes a historian, translating whispers written in stone. And yet, beneath that wonder lies melancholy. Time here feels heavy, suffocating in its endlessness. Each second adds to a weight that can be felt in the silence itself, pressing down on the planet's barren plains. There's no decay because there's no renewal, no death because there's no life, only persistence. To walk here would be to step outside of time, to feel the pause between creation and oblivion. The stillness would surround you like a presence, ancient and infinite, and as you looked across the rusted plains, you might realize that Mars doesn't keep time the way we do. It keeps memory. It collects it, grain by grain, storm by storm, until what remains is not a moment, but eternity, wearing the face of a planet. Once, water carved canyons the size of continents. Dry deltas still trace the memory of lakes that lasted 1,000 years and vanished. Mars remembers being alive, but like a photograph faded by sunlight, the memory is all that remains. Long before the red dust settled, Mars was a world of blue and motion. Rivers once threaded across its surface, carrying minerals, sediment, and the promise of life. Ancient lake beds shimmered beneath a younger sun, and valleys branched like veins across the land, connecting basins and floodplains that might have mirrored Earth's earliest dawn. It was a planet in its springtime, warmer, wetter, dynamic. The evidence is everywhere, written in the language of geology. Channels that twist like serpents, deltas that bloom like frozen flowers, and shorelines etched into the edges of craters long turned to stone. The Mars Reconnaissance Orbiter has photographed these ghosts in exquisite detail. River networks cut deep through the southern highlands, their channels braided and intertwined, frozen mid-flow. In places like Jezero Crater, where the Perseverance rover now searches, ancient sediment fans still hold the shape of deltas. They rise from the landscape like memories preserved in stone, each layer telling of tides, floods, and long, patient cycles of erosion. Billions of years ago, these rivers likely carried water from melting snow or rainfall, pooling into lakes that could have lasted thousands, perhaps millions of years. They may have supported entire ecosystems of microbes, sustained by minerals, warmth, and sunlight filtered through a thicker, friendlier atmosphere. The chemistry of these ancient waters left behind clays, carbonates, and salts, minerals that only form in the presence of liquid water. Every grain of dust that once lay beneath their waves is a fossil of motion, a trace of a time when Mars still breathed. But that age ended. The magnetic shield failed, the air thinned, and temperatures plummeted. Without protection, the atmosphere could no longer trap heat or hold water. Rivers dried, lakes evaporated, and oceans, if they existed, retreated into frost and vapor. What remains are the outlines of life's possibility, the channels carved by water that no longer flows. If you could walk those dry valleys now, you might still see their grace. The meandering paths of rivers that have not moved in billions of years still curve elegantly through the dust. Pebbles, smoothed by ancient currents, lie exactly where they fell. It's as if time itself stopped midstream, freezing the act of erosion into art. The sunlight touches these relics gently, tracing shadows through channels that once carried motion, laughter, and perhaps the whisper of something alive. Scientists believe that deep beneath the surface, some of that water remains, locked in ice or trapped as brine within the soil. Perhaps there are still aquifers, sleeping beneath kilometers of rock, where warmth from the planet's core keeps liquid water alive in darkness. And where there is water, there is always the question, is something still there, waiting? The ghosts of rivers do not haunt Mars with sadness alone, they also invite wonder. They remind us that planets, like memories, can change beyond recognition, yet still carry the essence of their beginnings. Mars may never flow again, but its surface is still shaped by the memory of movement. The dry riverbeds are not just remnants, they're reminders, proof that even a dead world can remember the sound of water, and in remembering, whisper to us about what it means to be alive. We imagine cities beneath glass domes, glowing softly against the dust. But each dome would be a coffin under pressure. One fracture, one grain of debris, and the vacuum wins. Mars doesn't forgive mistakes. The dream is easy to picture. Translucent habitats rising like lanterns across the red horizon, their surfaces glimmering in the thin sunlight. Inside, people walk without suits, gardens bloom beneath artificial skies, and laughter fills the recycled air. Humanity, triumphant at last, living beyond Earth. It's a beautiful fantasy, but physics doesn't care for beauty. On Mars, every structure, every breath, every pane of glass stands between life and nothingness. The air inside a Martian dome would need to be thick enough to mimic Earth's, pressurized, oxygen-rich, warm. The air outside, however, is little more than a vacuum. That means every square meter of the dome's surface would endure a crushing force, constantly trying to burst outward. The slightest weakness, a microfracture, a manufacturing flaw, a stray meteorite, could unleash disaster. There would be no explosion, no fiery end, just silence, as air rushes out faster than a scream can travel. Engineers propose layers upon layers of protection, flexible polymers, radiation-hardened glass, self-healing materials. The domes would not be crystal clear but tinted, shielded, layered like armor. Even then, the dangers remain. Mars's temperature swings violently, from mild afternoons to nights that could freeze metal. Materials expand, contract, and weaken with every sunrise. The dust, fine as smoke, seeps into seals and joints, grinding away at what little safety humans have built. To survive, colonies would likely need to go underground, carved into cliffs or buried beneath regolith to escape radiation and micrometeoroids. Those glowing domes we imagine might only be symbols, temporary shelters, observation decks, illusions of openness in a world that demands enclosure. Mars, in truth, would turn us inward, toward artificial light, metal corridors, and recycled breath. Inside such a dome, life would feel like living inside a heartbeat. You would always hear the hum of circulation fans, the hiss of oxygen pumps, the faint creak of metal expanding under pressure. You would sleep knowing that beyond a few centimeters of glass, the air is unbreathable, the cold immediate, the silence eternal. The mind, too, would strain under that pressure. The psychological weight of fragility, the awareness that safety is temporary, contingent, borrowed. In this way, a Martian city would be more like a shipwreck preserved in ice than a thriving town. Every system, air, heat, power, water, would have to work in perfect synchrony. One failure would cascade into another, and the thin margin between life and death would vanish. There are no natural backups on Mars. The planet itself offers no help, no mercy, only indifference. And yet, perhaps that fragility is what draws us. Humanity has always built domes against the impossible. The cathedrals of glass, the observatories of sky, the stations floating above Earth. We build them not because they are safe, but because they are daring. Because beneath every dome is a declaration, we are here, despite everything. Still, on Mars, that declaration would come with a price. Each transparent wall would be both window and warning, a reminder that survival here is an act of constant defiance. To live beneath a dome would not mean conquering Mars. It would mean acknowledging, every day, how close we stand to the edge of forever. Martian soil is filled with perchlorates, salts that poison water, burn the lungs, and destroy organic life. To grow even a leaf would require rebuilding the planet's chemistry from the atom up. At first glance, the ground looks promising. Rust-red soil, fine and soft, stretching endlessly across the plains. Surely something could grow there, given sunlight and care. But beneath that deceptive surface lies a silent hostility. The soil of Mars is not soil in the earthly sense, it's regolith, a mixture of volcanic rock, dust, and chemical residue sculpted by time and radiation. It holds no humus, no microbes, no memory of life. It is sterile, oxidized, and alien. On Earth, soil breathes. It's alive with bacteria, fungi, and organic matter that nourish the roots of every living thing. But on Mars, radiation has stripped away that invisible ecosystem. The sun's ultraviolet rays, unfiltered by atmosphere or ozone, have sterilized the surface completely. What remains is chemically reactive and biologically empty, a substance that destroys rather than sustains. Perchlorates, the salts found across the Martian surface, are the greatest obstacle. They make up about 0.5% of the regolith, enough to turn water into a toxic solvent. When dissolved, they break apart into chlorine and oxygen, corroding living tissue and disrupting metabolism. For humans, exposure to perchlorates can damage the thyroid and lungs. For plants, it is instant death. Every droplet of moisture would carry poison to the roots, transforming water, the very essence of life, into a weapon. To farm on Mars would mean reinventing agriculture itself. Scientists imagine sealed greenhouses filled with Earth-imported soil, purified water, and artificial light calibrated to mimic the warmth of the sun. Inside, machines would scrub the air, regulate pressure, and recycle every molecule. Each tomato, each blade of lettuce, would be a triumph of engineering over nature, a fragile victory against an environment designed to erase. Even with all that effort, the regolith itself would still fight back. It's sharp, abrasive, and magnetic. It clings to everything, grinding into seals and machinery. If used without processing, it would tear at roots and clog irrigation systems. To cleanse it, we would need to heat it to hundreds of degrees to drive out toxins, or wash it with solvents we'd have to ship or produce locally. Each handful of Martian dust would demand more energy than it could ever return in calories. And then there is the question of nutrients. The soil lacks nitrogen, the foundation of life's chemistry. It has no organic carbon, no bacteria to fix it, no worms to till it. It is, in every sense, a dead medium. To grow life here is to create life's context from scratch, to build an ecosystem atom by atom, process by process. Even the simplest seed would need an entire world built around it. Yet, despite all this, humanity keeps dreaming of green on red. We picture rows of crops beneath glass domes, glowing in artificial twilight. We imagine farmers tending leaves under the soft hum of generators, turning dust into nourishment. Because in that image lies something deeper than survival. It's hope. The hope that even in a sterile world, life might find a way to bloom again. The impossible harvest may never come easily, or at all. But perhaps that's the point. Mars reminds us that growth is never guaranteed, that life is precious precisely because it struggles against entropy. If a single leaf ever opens under a Martian sky, trembling in the thin air, it will not just be a plant, it will be a declaration, a whisper across the void that says, life can still begin, even where everything has ended. Every calorie consumed on Mars must come from machines powered by sunlight or nuclear heat. Food isn't grown, it's manufactured. And the cost of one meal could power a village back on Earth. On our planet, food is the most natural form of energy exchange imaginable. Seeds reach towards sunlight, rain falls, and soil returns its gifts to life. We eat the result of millions of years of effortless balance, an ecosystem where the sun feeds the leaf feeds the animal, and the cycle continues. But on Mars, that ancient contract is broken. There is no rain, no fertile soil, and no protective sky. Here, food doesn't grow, it must be engineered from scratch, molecule by molecule. In this fragile equation, energy becomes the new soil. Every plant would depend on power, not sunlight directly, but filtered through layers of life support. LED arrays to mimic solar radiation, hydroponic pumps to circulate water, and heaters to fight the cold that seeps through metal walls. A single potato or stalk of wheat would carry with it the invisible cost of watts and reactors. Calories that once came freely from the sky would now require the constant hum of machines. Even sunlight itself is unreliable. Mars receives only about 43% of the light that Earth does, and during months-long dust storms, that light fades to near darkness. Solar panels choke under layers of fine dust, and the weak daylight turns copper and dim. Nuclear reactors become the only dependable source of heat and energy, glowing hearts of human ingenuity buried in permafrost, powering greenhouses that hum like mechanical forests. Inside those domes, the air would be thick with humidity and hum with machines. Rows of plants might grow in nutrient-rich solutions, their roots dangling in the glow of artificial light. The room would smell faintly of ozone and iron, not Earth. Every leaf would be a triumph of control, temperature, chemistry, and light, orchestrated with precision. But there would be no bees, no soil, no sound of rain, only the whir of pumps and the quiet breathing of people who know that a single power failure could starve them all. Each meal would carry a story of energy expenditure. To grow a kilogram of vegetables might demand hours of reactor output. A loaf of bread could be measured in kilowatt hours. The math of survival would replace the poetry of agriculture. On Mars, food is not nourishment gifted by nature. It's the byproduct of persistence. The colonists who sit to eat would understand this intimately. Every bite would remind them of the fragility of their world, the layers of technology between them and hunger. In the faint glow of artificial dawn, they might imagine the taste of rainwater on fruit, or the scent of freshly tilled soil. Things Mars has never known. They would learn that food is not just sustenance, but memory. And yet, perhaps this hardship would bring gratitude back to the act of eating. On Earth, abundance dulls appreciation. On Mars, survival sharpens it. Every grain of rice, every leaf of lettuce would represent the collective endurance of a species refusing to surrender. Mars will never feed us the way Earth does. But maybe that's the lesson. It teaches us that every meal is a miracle of balance, every bite an energy exchange older than stars. And when we finally understand that, we may learn to cherish the abundance of home all over again. The closest Mars ever comes to Earth is 54 million kilometers away. Communication takes minutes. Rescue takes months. On Mars, help is not delayed, it is impossible. In the endless vacuum between worlds, distance is not measured in kilometers, it's measured in time, silence, and isolation. At its nearest, Mars seems almost within reach, a glowing ember drifting beside us in the dark. But even then, the gulf between planets is vast enough to swallow everything familiar. A signal from Earth takes anywhere from 3 to 22 minutes to arrive. Words spoken now echo into a future no one can answer in real time. On Mars, conversation itself is stretched by the speed of light. For astronauts or colonists, that delay transforms every decision into an act of faith. A malfunction, an injury, an unexpected storm, none of it can summon instant guidance from home. Mission control becomes a ghostly presence, responding to events already past. By the time a solution arrives, reality may have already shifted. You are not just living far from Earth, you are living behind it, perpetually a few minutes out of sync with everything and everyone you've ever known. The psychological weight of that silence would be immense. Humans are built for response, for call and answer, for comfort in immediacy. On Mars, silence becomes the dominant language. Between transmissions, between pings of data, there is nothing but the faint hum of your own machines and the heartbeat in your ears. The delay, though only minutes, stretches into eternity when danger looms or loneliness deepens. And rescue. Rescue is a myth. Once the launch window closes, you are sealed to the planet for months, maybe years. The orbits of Earth and Mars dictate every journey, and their rhythm cannot be rushed. If something goes wrong, a system failure, a medical emergency, an accident, there is no evacuation plan, no cavalry on the way. The time it would take to send a ship, even traveling at incredible speed, is longer than most emergencies can endure. On Mars, survival is self-contained. Help will never come. This distance also transforms the simplest human experiences. A message from loved ones becomes an artifact of the past. A voice arriving long after it was sent. You could send "good morning" and receive "good night." The very idea of now becomes blurred between worlds. The present, once a shared moment, fractures into separate timelines, separated by millions of kilometers and the speed of light. And yet, distance has its quiet gifts. The farther we travel, the more we see of ourselves. To look back from Mars and see Earth as a tiny blue star, glowing against the black, would be to witness home stripped of boundaries and noise. Every city, every ocean, every story reduced to a single point of light. You would realize, perhaps for the first time, how small the world really is, and how connected we all remain despite the void. But that beauty does not erase the truth. Mars is not a neighbor. It's a frontier defined by isolation. Distance here is not a line on a map. It's a wall of time and silence that no technology can yet tear down. To live on Mars would mean learning to exist beyond reach, to accept that every heartbeat, every word, every breath is an act of independence. On Earth, we call across oceans. On Mars, we call across eternity. A radio signal from Earth takes up to 22 minutes to arrive. You speak, then wait, surrounded by silence. Each conversation feels like talking to the past and listening to ghosts. It is one of the cruelest paradoxes of space travel. Even in the age of instant communication, Mars exists beyond the reach of real-time connection. When you speak, your words travel at light speed through the cold emptiness, a pulse of energy cutting across millions of kilometers. Yet even light, the fastest thing in the universe, moves too slowly to bridge the loneliness. By the time your message reaches Earth, it is already history. By the time the reply returns, so are you. Imagine it. You sit in your small habitat, the walls faintly humming, the recycled air carrying the dry tang of metal and dust. You press a button, speak into the radio, and send your voice home. Then, nothing. For 22 minutes, there is only the steady hum of machinery and the sound of your own breathing. You wait for an echo that hasn't yet begun its journey back. When it finally comes, it's like hearing yourself from another lifetime. Every conversation becomes an exchange with the past. "How are you?" asked from Mars. Answered half an hour later by someone who doesn't yet know what's happened since. Laughter, comfort, grief, everything arrives out of sync. A joke loses its timing. A cry for help becomes a message in a bottle. Even reassurance, when it comes, feels too late. The lightspeed barrier is an invisible wall that separates every thought by minutes, every heartbeat by universes. For mission control, this delay is more than an inconvenience, it's a challenge to survival. Commands to rovers and habitats must be sent hours in advance, with predictions and preemptive corrections. Humans on Mars would need to become their own engineers, doctors, and navigators. There is no real-time guidance, no instant backup, no comforting voice in the ear, just silence and protocol, and the growing understanding that the only one who can save you is yourself. But the psychological toll runs deeper. On Earth, silence is peaceful. It has texture, birds, wind, waves. On Mars, silence is absolute. There is no ambient sound, no natural rhythm to remind you you're not alone. The planet is still, the air too thin to carry noise. When the radio cuts off, it feels like the universe itself is holding its breath. In that vacuum, time stretches, thought expands, and memory becomes both comfort and curse. Astronauts and psychologists have long studied what such solitude does to the mind. Isolation bends perception. Without feedback, the human brain begins to fill the gaps, to imagine footsteps in the static, whispers in the static hiss, patterns in the silence. It is not madness, but survival, a mind trying to recreate the social world it has lost. And yet, some might find beauty in the delay. To speak across such a distance is to participate in something cosmic, a conversation measured not in words, but in light years of patience. The gap between question and answer becomes a meditation, a mirror for reflection. Each pause, each minute of silence is a reminder of how vast the universe is and how fragile connection can be. On Mars, every word becomes sacred simply because it must travel so far. Every hello is a tiny act of defiance against the infinite, and in that long delay between transmission and reply, you can almost feel the pulse of two worlds breathing in time, separated by light but bound by longing. Every 26 months, Earth and Mars align for launch. Miss that window, and you wait over 2 years. Time itself becomes another form of gravity, holding you in place against your will. On Earth, travel is a matter of distance. You cross oceans, continents, and hemispheres, carried by engines that shrink the world to hours. But between Earth and Mars, travel isn't about distance, it's about timing. The planets orbit the Sun at different speeds, and only when their paths align in a narrow celestial rhythm can a spacecraft make the journey efficiently. These brief alignments, launch windows, open like cosmic doors and close just as quickly. Miss one, and you are stranded until the planets meet again. For those on Mars, the knowledge is suffocating. Once the launch window closes, you are truly isolated, sealed inside an invisible cage of orbital mechanics. The next ship won't come for nearly 2 Earth years. Even if Earth wanted to send help, it couldn't, not quickly, not cheaply, not without risking lives and resources. On Mars, the concept of rescue doesn't just fade, it becomes irrelevant. Time itself is the border. That knowledge reshapes everything. Supplies must last through multiple Martian years. Every resource, oxygen, water, food, power, is calculated with no margin for error. A broken part cannot be replaced. A mistake cannot be undone. You live under the weight of cycles that belong to the universe, not to you. Days might feel long, but the wait between ships feels geological. You are living on a clock built for planets, not people. Imagine the view from a Martian dome as the window closes. The Earth shrinks into a pale star in the sky, a single pixel of blue that carries everyone you've ever known. You watch it set, knowing that the next rocket, the next voice, the next piece of mail won't arrive until long after another winter has passed. The horizon feels heavier for it. Even the dust seems to move slower, as if time itself were thick with distance. Psychologically, that delay would erode even the strongest minds. You could measure your life not in days or seasons, but in orbits, counting the long dance of 2 worlds circling the sun. Birthdays, holidays, messages from home, all lose their synchronization. You exist out of phase with humanity, a traveler marooned in time. Even light, the fastest messenger of all, can't keep up with your longing. And yet, in that endless wait, there is a strange beauty. The alignment of worlds is a celestial heartbeat, steady and precise, reminding us that everything in the universe moves in cycles. The same mathematics that traps us also connects us. When that window finally opens again, and a new ship burns through the thin Martian sky, it is not just an arrival, it is a renewal, the next verse in an ancient rhythm written in gravity and light. But for those waiting on the surface, time is the truest adversary. It is invisible, untouchable, yet heavier than the planet beneath their feet. On Mars, you learn that isolation is not defined by distance, but by waiting. And when you gaze at the faint glimmer of Earth, suspended in the dark, you feel it fully. The weight of 2 years, the pull of 2 worlds, and the long, unbroken silence between them. Mars has no birds, no oceans, no sound. The silence here isn't peace, it's absence. Even the human mind begins to unravel in such quiet, inventing whispers just to feel less alone. On Earth, silence is never truly silent. Even in the stillest night, you can hear the faint rhythm of existence, the chirp of insects, the pulse of distant waves, the soft rush of wind through leaves. These sounds are more than background noise, they are reassurance, proof that you're part of something living. But on Mars, that music is gone. The air is too thin to carry sound, and the planet itself has forgotten how to speak. There are no rustling forests, no rolling thunder, no heartbeat of the ocean, only wind, an endless whisper over stone. At first, that stillness might feel sacred, the kind of quiet you could lose yourself in, vast and eternal. But over time, it changes. The mind, deprived of familiar cues, begins to fill the void. A scrape of metal, a hiss of air, suddenly magnified, analyzed, obsessed over. Your own breathing becomes intrusive, every heartbeat echoing too loudly in your ears. In the absence of sound, your thoughts start to echo instead, circling endlessly through the corridors of your own skull. Psychologists call it sensory deprivation, but on Mars, it would be a way of life. Without external rhythm or natural noise, the human brain struggles to maintain balance. It seeks pattern, conversation, feedback. In the long silence between communications, colonists might begin to imagine voices in the hum of machinery or footsteps in the dust. The boundary between real and imagined sound would blur until both felt necessary. It's not madness, it's adaptation. The mind reaching out, desperate for the illusion of company. Inside a habitat, the mechanical hum becomes a lifeline. The soft vibration of oxygen pumps, the rhythmic thrum of air recyclers, the faint hiss of pressure regulators, all form a kind of artificial heartbeat. Lose that sound, and terror sets in. Silence, on Mars, isn't just eerie, it's deadly. The absence of noise could mean a system failure, a rupture, the beginning of catastrophe. Here, silence doesn't soothe, it warns. Step outside, and the quiet deepens into something cosmic. Even the roar of wind sounds wrong, thin, ghostly, carried more by vibration through your suit than by the atmosphere itself. The horizon stretches endlessly, but there's nothing to break the stillness. The only voice you'll ever hear out there is your own, echoing faintly inside your helmet. Over months, this quiet would begin to change perception itself. The brain might slow down, thoughts stretching to fill the empty space. Memory would feel sharper, emotions heavier. In solitude this complete, even time feels different, smeared, elongated. The lack of sound becomes a lack of momentum. The days blend together, and the only proof that life continues is the soft, mechanical pulse of the machines that keep you alive. And yet, perhaps within that silence lies something profound. Beneath the fear and unease, there is also awe. In a world that has forgotten noise, your breath becomes a sacred thing. The sound of your own voice, a miracle. You realize how precious sound truly is. The laughter of a friend, the whisper of trees, the song of rain. Mars teaches the value of sound by taking it away. In its absolute stillness, it shows us what it means to be alive, not by what we hear, but by what we miss. And somewhere in that infinite quiet, surrounded by dust and eternity, you begin to understand that silence isn't empty at all. It's the universe listening back. On Mars, bone density drops, red blood cells falter, vision changes. The body slowly transforms into something that cannot survive where it was born. Colonization isn't just exile, it's evolution in slow motion. The human body is a masterpiece of adaptation, but it's an adaptation tuned to one world. Every heartbeat, every stride, every cell in our bones evolved beneath the steady pull of Earth's gravity, the warmth of its atmosphere, and the balance of its air. On Mars, that equilibrium unravels. The body must learn a new physics, lighter gravity, thinner air, harsher radiation, and in doing so, it becomes something alien to its own origins. At first, the change feels gentle. Walking in Martian gravity, barely 1/3 of Earth's, seems almost liberating. Movements feel effortless, leaps become graceful arcs. But beneath that grace, the body begins to deteriorate. Muscles built for resistance find too little to push against. They weaken, shrink, and forget. Bones, deprived of constant pressure, start to dissolve calcium back into the bloodstream, becoming porous and fragile. A colonist who once ran on Earth would, after a few years, struggle to stand if they returned home. The circulatory system changes too. On Earth, gravity pulls blood downward, and the heart pumps against that pull. It weakens, reshapes, and adapts to a world where effort is optional. The result is paradoxical, a body that functions perfectly on Mars, but would collapse under Earth's weight. Gravity itself becomes a kind of memory, and over time, a forgotten language. Even blood begins to behave differently. Red blood cells decrease, oxygen distribution shifts, and circulation slows. The body, never fully comfortable in the thin Martian air, compensates by altering its chemistry. The lungs expand their capacity, the chest subtly reshaping to gather what little oxygen exists within a habitat's controlled environment. In this new physiology, Survival means constant recalibration. Radiation adds another layer to this slow metamorphosis. Without Earth's magnetic shield, every living cell on Mars absorbs a constant drizzle of cosmic rays. DNA frays, repair mechanisms overwork, and aging accelerates. Cancer, mutations, and chronic fatigue become not diseases, but conditions of existence. To be human on Mars is to be perpetually wounded by light. The eyes, too, begin to change. On Earth, sunlight scatters through a thick atmosphere. On Mars, it's harsher, bluer, and filled with ultraviolet glare. The optic nerve strains against the brightness, the brain adjusting to a world without depth or haze. Many astronauts in microgravity report altered vision, flattened eyeballs, blurred sight, pressure changes. On Mars, these effects might become permanent. Even the way humans see would evolve away from what Earth designed. And then there's the mind. Isolation, confinement, and alien landscapes reshape psychology as profoundly as gravity reshapes the skeleton. Sleep cycles drift, circadian rhythms falter beneath twin moons and pink sunsets. The brain begins to adapt to a slower, quieter rhythm, a Martian tempo of thought. Over generations, the differences would grow profound. Children born on Mars would know only 1/3 gravity. Their bodies would stretch taller, their hearts smaller, their bones lighter. Returning to Earth might be fatal. The two species, Earthborn and Marsborn, would diverge not by choice, but by biology. Mars would not just be a place humanity inhabits, it would be a place that rewrites humanity itself. And perhaps that's the most haunting truth of all. To colonize Mars isn't just to leave Earth, it's to leave humanity as we know it. To plant our flag on another world is to begin a new branch of evolution, one that may never come home. Mars will not kill us quickly. It will change us slowly, until the bodies that walk its surface no longer remember the gravity, the breath, or the warmth of the world that made them. Martian dust is finer than smoke and sharp as glass. It infiltrates everything: joints, wires, lungs. It clings electrostatically, devouring the machinery designed to keep us alive. On Earth, dust is an afterthought, a nuisance to sweep away, a film that settles on forgotten shelves. But on Mars, dust is a force of nature, a silent predator that never stops moving. It floats through the thin air in clouds of rust, stirred by winds that never rest, and settles on every exposed surface like a patient infection. Each grain is smaller than a speck of flour, yet harder than steel, born from volcanic rock ground to microscopic shards by eons of erosion. Under a microscope, Martian dust is not smooth, it's jagged, crystalline, and hungry. When it moves with purpose. Static electricity charges each particle, making it cling to anything it touches: metal, plastic, glass, even the suits that protect human skin. It creeps into hinges and seals, into circuit boards and solar panels, shorting, grinding, corroding. Machines that worked flawlessly on Earth find themselves choking on the red haze of this alien world. Every rover that's touched Mars has fought this enemy. Spirit and Opportunity both struggled as dust coated their solar arrays, dimming their power until they could no longer wake. Insight, the lander that listened for Marsquakes, fell silent after its panels darkened beneath a layer of fine grit. Even the mighty Curiosity, powered by nuclear energy, feels the slow abrasion, its joints wearing down, its instruments scratched by particles carried on whisper-thin winds. On Mars, entropy doesn't come from time, it comes from dust. For future colonists, the challenge is existential. Habitats, vehicles, and suits must be sealed with precision bordering on perfection. Filters must run constantly to trap airborne dust before it can reach the lungs or lungs' mechanical equivalents. Every time an airlock opens, every time a rover returns, microscopic invaders come with it. They coat interior walls, settle into gears, scratch visors, and worse, perchlorate salts in the dust are toxic, reacting with moisture in the lungs to release chlorine. To breathe Mars unfiltered, even for a moment, would be to inhale poison. And yet, you cannot escape it. Dust storms can envelop the entire planet, lifting billions of tons into the atmosphere. They blot out the sun, changing daylight to dusk, turning the sky into a sepia blur. When the storm passes, a red residue coats everything, a thin, omnipresent film that seems to whisper, "I am still here." The battle against Martian dust is not fought once. It is constant. Every seal checked daily, every circuit cleaned, every suit brushed before re-entry. Humans would live in a world that demands maintenance as worship, a ritual of survival against the smallest enemy imaginable. Still, there is something poetic in this war. The dust that destroys is also the planet's memory. Each particle carries the story of ancient volcanoes, of rivers long vanished, of meteor impacts and magnetic fields long dead. In destroying machines, it reminds us that this world is not ours to tame. It is a relic of cosmic time. One day, perhaps, our machines will learn to coexist with it, to filter, repel, or harness the dust that now defies us. Until then, every rover that falls silent becomes part of the planet's surface, reclaimed by the very dust it once studied. On Mars, everything returns to red in the end. Machines, footprints, dreams, all erased softly by the finest sand in the solar system. Without a magnetic field, cosmic rays rain freely on Mars. Invisible, relentless, they slice through DNA like knives through silk. Colonists would live under constant bombardment, aging faster, mutating quietly. On Earth, we live within a cradle of protection. Our magnetic field and thick atmosphere work in tandem to deflect and absorb the cosmic violence of space. Every second, our planet shields us from high-energy particles born in supernovae and the sun's flares. But Mars has long since lost that shield. Its core cooled, its dynamo died, and with it went the magnetic cocoon that once held the storms at bay. Now, Mars stands exposed beneath an unfiltered universe, a world perpetually bathed in invisible fire. Cosmic rays are not gentle. They are fragments of atoms traveling near the speed of light, protons, heavy ions, the shattered debris of distant explosions. When they strike human tissue, they don't simply stop. They penetrate deep, ionizing molecules, tearing through DNA and leaving microscopic scars in every cell. A single high-energy particle can slice through chromosomes like glass through water, breaking the code that sustains life. On Earth, our atmosphere absorbs almost all of them. On Mars, they reach the surface unhindered. Inside a habitat, colonists would find some refuge. But not complete safety. Metal walls only slow the storm, some particles pass through, and worse, they can trigger secondary radiation. Bursts of new particles created as the originals collide with matter. Each shelter becomes both shield and source, a paradox of protection that never feels complete. To live on Mars would mean learning to coexist with radiation, to measure exposure not in days, but in lifetimes. Outside, the risk multiplies. A walk on the Martian surface is not just exposure, it's endurance. A single solar flare could flood the planet with charged particles, raising radiation levels to hundreds of times what Earth's surface experiences. During such events, colonists would have to retreat underground or into shielded modules, waiting for the storm to pass. But the cruel truth is that some radiation cannot be escaped. It comes from every direction, every moment, a steady drizzle of death written into the fabric of space itself. The consequences are slow, silent, and irreversible. DNA damage accumulates. Cells mutate or die. The immune system weakens, repair mechanisms falter, and aging accelerates. Cancer risk skyrockets. Neurological effects creep in over time. Cognitive fog, memory loss, emotional instability. Even blood cells, constantly dividing to renew life, suffer under the onslaught. In every sense, radiation reshapes what it means to be human. That transformation isn't always visible. It hides in the marrow, the brain, the unseen architecture of life. A colony on Mars would, over generations, bear the signature of radiation like a watermark, a quiet mutation passed from parent to child. Perhaps new tolerances would emerge, a slow adaptation to an irradiated world. Evolution, once driven by sunlight and air, might begin again under cosmic fire. Some dreamers imagined vast underground cities carved into the rock, protected by meters of regolith. Others pictured domes covered in water or ice, nature's best shield against radiation. In theory, such sanctuaries could preserve humanity's form, but not its dependence on safety. The knowledge that the world outside is uninhabitable, that the very sunlight carries death, would weigh heavily on the psyche. The red planet would not feel like a new home, but a bunker beneath an eternal storm. And yet, there is awe in that danger too. Those same cosmic rays that threaten to unmake us are also the messengers of the universe's greatest events: supernovae, black holes, the birth of stars. Every particle that strikes Mars carries with it a story written across light years. To live on Mars would be to exist within that cosmic rain, to feel, quite literally, the touch of the stars. But survival would demand humility. To colonize Mars is to live beneath a storm that never ends, a storm of energy and time itself. The sky may look calm and still, but above that thin veil of atmosphere, the universe is roaring, and Mars has no defense against its song. To warm a single habitat takes the power of a small town. To terraform the planet would require more energy than humanity has ever produced in its entire history. Mars is not cold, it is hungry. Every part of Mars resists warmth. The planet's thin atmosphere, barely 1% the density of Earth's, cannot hold heat. Sunlight, when it reaches the surface, scatters off iron dust and vanishes into the void. Even at noon, standing beneath a pale, distant sun, you would feel almost nothing. The light looks bright, but it carries no comfort. Heat simply refuses to stay. Mars is a planet where warmth bleeds away faster than it can be made, where energy itself seems to vanish into the silence. Inside a habitat, survival depends on the constant hum of power. Life support systems must run endlessly: heaters, oxygen generators, carbon scrubbers, radiation shields, hydroponic lights, and pressurizers. The moment they fail, the cold returns, swift, merciless, absolute. It seeps through metal walls, through glass and seals, through everything humans can build. The colonists would live not beside warmth, but inside it, sustained only by the energy they can feed to their fragile machines. The numbers are staggering. To keep a small habitat habitable, just a few rooms, enough for a handful of people, requires roughly the output of a few megawatts, the energy of a modest town on Earth. Every breath, every drop of water, every hour of light is bought through power, and power, on Mars, is precious. Solar panels are unreliable. Under its dim and dusty skies, their efficiency crippled by the very dust that defines the planet. Nuclear reactors might last longer, but they must be built, transported, maintained, each a small sun burning in a world of frost. And what of the dream of terraforming, the grand vision of turning Mars into another Earth? It is a fantasy painted in energy and impossibility. To thicken the atmosphere, you would need to release enough carbon dioxide to raise pressure and temperature globally. To melt the ice caps and awaken rivers, you would need the heat of trillions of bombs. Every calculation leads to the same conclusion. The power required exceeds all the energy humanity has ever generated. Even if we burned every barrel of oil, every gram of uranium, every photon of sunlight we could harness, it would not be enough. The planet's cold is not simply temperature, it's inertia. It resists change with the weight of physics itself. Any warmth we bring is fleeting, like a match struck in a blizzard. The surface radiates heat back into space as fast as we can create it, a planetary mirror reflecting our effort into nothingness. Mars doesn't just need energy, it consumes it, endlessly, hungrily, without return. This hunger extends beyond thermodynamics. Every process on Mars costs more: fuel to lift supplies from its surface, power to recycle air, energy to mine ice or make water. Even rest demands electricity. On Earth, warmth is a gift. On Mars, it's a transaction that never ends. The red planet devours everything we give it and asks for more. Yet perhaps that's what draws us. Mars is not a world that welcomes life. It's a world that demands it fight for every second. To survive, there is to defy nature's indifference, to pour light and heat into a place that has forgotten both. It's a battle against entropy on a planetary scale, and in that struggle lies meaning. Mars is not cold because it lacks sunlight. It is cold because it refuses to yield. It doesn't freeze in stillness. It hungers in silence. And to live there, to truly claim it, humanity must feed that hunger with everything it has, with energy, with will, with hope itself, just to keep the dark at bay. We dream of turning Mars blue again, melting the poles, thickening the air, awakening oceans. But Mars has no magnetism to hold an atmosphere, no volcanic heart to renew itself. Even if we succeed, the wind would strip it all away again. Terraforming Mars is one of humanity's grandest visions, a dream of resurrection on a planetary scale. The image is intoxicating: rivers threading through red canyons, clouds drifting across a restored sky, trees swaying beneath a softer sun. In imagination, Mars becomes not an exile, but an extension of home. Yet the physics of reality stands in quiet opposition. The dream of a green Mars fades the moment we confront what the planet truly is. Not a dormant Earth, but a world fundamentally broken. At its core, Mars lacks the one thing every living world needs: motion. Its magnetic field, once born from a molten, churning core, is long gone. That field was a shield, a barrier against solar wind, protecting the planet's atmosphere from being stripped away molecule by molecule. Without it, Mars stands naked beneath the solar storm. Any air we might give it, any breath we might build, would simply drift into space, peeled off by invisible hands. A terraformed Mars would be temporary, a fragile illusion slowly erased by the same forces that killed the first one. Some have suggested we could melt the polar caps to release carbon dioxide, thickening the air enough to trap warmth. But modern measurements reveal there isn't enough CO2 there to matter. Even if we vaporized all of it, the planet's pressure would rise only slightly, still far too thin for liquid water or human lungs. We could import gases, detonate nuclear devices to heat the surface, or blanket Mars in mirrors to focus sunlight. Yet every solution collapses beneath the same truth: Mars cannot hold what we give it. It leaks life into the void. And without volcanic activity, there is no engine to replenish what's lost. Earth's atmosphere is alive. It breathes through oceans and eruptions, through decay and renewal. Mars, in contrast, is geologically tired. Its volcanoes, Olympus Mons, and its siblings stand like tombstones, reminders of a world that once moved, once breathed, but they are silent now. The planet's heart has cooled. There is no carbon cycle to sustain an atmosphere, no tectonic motion to recycle the crust, no chemical pulse to balance the air. Terraforming such a planet is not restoration, it's reanimation. Even if, by some unimaginable feat, we succeeded, if Mars were wrapped in clouds and seas again, it would still not last. Over centuries, perhaps millennia, the same fate would reclaim it. Solar wind would erode the upper atmosphere. Radiation would shatter molecules. Dust storms would obscure the sky, and the warmth would fade. The new seas would freeze, the air would thin, and the dream would collapse back into dust. Terraforming, then, is not merely a technological challenge, it's a philosophical one. It asks whether we can truly change the nature of a world, or whether some things in the universe resist our will entirely. Mars reminds us that not all frontiers can be conquered, not all silences can be filled with life again. Perhaps, in time, we'll learn that the beauty of Mars lies not in what it could become, but in what it reveals, that even desolation can be magnificent, that a planet does not need oceans to be worthy of awe, and that sometimes the hardest truth for explorers to accept is this: some worlds are not meant to be remade. Every atom we add, every molecule of oxygen we release, will flee into space. Without a shield, Mars cannot keep what it's given. Terraforming it would be like filling a sieve with water. Mars looks steady and eternal from afar, but it is a world that is always slipping away. Its greatest wound is invisible: the slow, constant loss of its sky. The thin veil of air that remains is a remnant, a memory of a once thicker atmosphere, stripped over billions of years by the relentless breath of the sun. Today, the Martian air is so thin that water boils on the surface and sound barely travels through it. But even that whisper of atmosphere is not safe. It is still vanishing, atom by atom, into the black. The culprit is the solar wind, a stream of charged particles flowing outward from the sun at hundreds of kilometers per second. On Earth, our magnetic field bends this wind harmlessly around us, forming shimmering auroras at the poles. Mars, without that protection, stands naked before it. Every moment, these solar particles crash into the upper layers of the Martian atmosphere, knocking atoms loose and flinging them into space. The process is slow but relentless, a cosmic erosion that has transformed Mars from a world of rivers and rain into one of dust and silence. NASA's MAVEN spacecraft has been watching this process unfold in real time. It measures oxygen and carbon dioxide escaping into the void, tracing the steady unraveling of a planet's sky. Even now, billions of years after the loss of its magnetic shield, Mars continues to bleed. If we tried to rebuild its atmosphere, to pump oxygen from rocks, to release carbon dioxide from its frozen poles, the result would be temporary. The same forces that destroyed its past would simply destroy its future. The physics is merciless. Without pressure or protection, gases drift upward, spreading thinner until sunlight itself breaks them apart. Ultraviolet radiation splits oxygen molecules into atoms, stripping electrons and sending them sailing into space. Even the heaviest gases eventually escape, carried away on solar tides that never stop flowing. Mars is not simply barren, it is porous, unable to hold on to the very ingredients of life. Some dreamers propose giant magnetic shields placed in orbit, artificial magnetospheres to guard Mars from the sun. Others imagine building vast industries to constantly replenish lost gases, maintaining a fragile balance forever. But such solutions are Sisyphean. The energy required would rival that of a star, the maintenance would last longer than civilizations. For every breath we add, the void would take one back. The equation always ends the same way: loss. This truth reframes the dream of terraforming. It's not a matter of technology, but of permanence. What good is a sky that won't stay? What meaning does an ocean have if it must be remade every century? Mars, for all its beauty, is a leaking vessel in space, a reminder that not all worlds are meant to hold life. And yet, perhaps there's a kind of poetry in that futility. The act of trying to breathe life into a planet that cannot keep it is profoundly human. We build castles in sand, knowing the tide will come. We light fires knowing they will fade. To fill a sieve with water is an act of faith, a refusal to surrender to inevitability. In the end, Mars teaches us humility. It is not a world to be conquered, but one to be understood. Its vanishing sky reminds us that life is rare precisely because it is fragile, and that even the air we breathe is a gift that the universe does not easily give. Venus is too hot, Mars is too cold. Between them lies a narrow miracle called Earth. To colonize Mars is to stand on the edge of that miracle and realize how thin the line of habitability truly is. Our solar system is a lesson written in temperature and distance. 3 worlds, born of the same dust, orbit the same star, yet diverged into radically different fates. Venus, cloaked in clouds of acid, burns at nearly 500 degrees Celsius, a world where metal melts and rain falls as poison. Mars, stripped of its air, freezes at 60. Its rivers turn to glass. Between them spins Earth, balanced on a razor's edge, the only place where oceans shimmer and air embraces life. The difference between paradise and oblivion is measured not in light years, but in fractions of sunlight. Venus and Mars are mirrors, each reflecting a warning. Venus shows what happens when a planet holds too much atmosphere. Mars shows what happens when it loses too much. One suffocates beneath its own heat. The other starves in the cold vacuum of space. In that symmetry lies a profound truth. Habitability is fragile, dependent on a balance so precise that even the smallest cosmic nudge can undo it. When we dream of colonizing Mars, we rarely consider that we are attempting to live on the far edge of survivability. Mars sits beyond the Goldilocks zone, where liquid water can exist only fleetingly. Its sun is weak, its air thin, its warmth transient. Every breath, every sip of water, every moment of comfort must be manufactured. To live there is to stand outside the narrow band of nature's grace, and to realize just how much Earth gives without asking anything in return. Venus, in contrast, serves as a cautionary tale of excess. Once, it may have had oceans too. Shallow seas that boiled away as greenhouse gases trapped heat faster than the planet could shed it. Over time, carbon dioxide built up, thickening the sky until it became a furnace. The air pressure on Venus is 90 times that of Earth's. The temperature never drops below what would melt lead. The planet's surface is not a landscape. It's a crucible. Forever burning under a sun it can no longer escape. Mars, on the other hand, is the story of too little, of a world that cooled too fast, lost its magnetism, and watched its atmosphere drift into space. The difference between Venus and Mars is a difference of fate, but also of gravity and time. Earth, with its molten core and active geology, maintains a balance that both neighbors lost. Our world breathes, theirs have fallen silent. To look at Mars from this perspective is to see it not as a new frontier, but as a warning written in rust. It shows us how thin the conditions for life truly are, how narrow the bridge between flame and frost. We live within a cosmic coincidence, a brief window of perfection that may never be repeated elsewhere. Standing on Mars, looking back at Earth, a glowing blue marble framed by endless black, you would see that truth with unbearable clarity. You would understand that habitability is not guaranteed, that the universe does not promise comfort. Earth's balance is not normal, it is extraordinary. Venus burned, Mars froze, and in the fragile space between, we found home. To colonize Mars is not merely to explore, it is to remember. To remember how rare life is, how delicate the balance must be, and how easily it can be lost. On Mars, even air must be mined, processed, and paid for. Each inhale becomes a calculation. Oxygen becomes currency, and life itself an economic system. On Earth, we never think about breathing. It is the one act that unites all living things, free, effortless, and infinite. The air surrounds us in abundance, a gift so constant we forget it's a miracle. But on Mars, that same act becomes a transaction. Every breath a person takes would pass through layers of engineering, energy, and logistics. Each molecule of oxygen, a product of effort, machinery, and maintenance. Breathing there is not natural, it's an act of sustained defiance. The Martian atmosphere is nearly 95% carbon dioxide, thin, toxic, and deadly. To survive, oxygen must be extracted from what little is available, either from CO2 itself or from buried ice. NASA's MOXIE experiment aboard the Perseverance rover proved it's possible to make breathable oxygen on Mars, just enough for a single astronaut for an hour. But scaling that up to sustain a colony would mean building entire cities of machines, constantly humming, splitting molecules day and night, powered by reactors that must never fail. Imagine living in such a world. Each breath you take has a price. Energy expended, systems maintained, filters replaced. You would know the source of every inhalation, the electrolysis chamber that extracted it, the solar array that powered it, the technicians who kept the compressors alive. Oxygen would be metered like water or fuel, measured in liters per minute, rationed when power dips or storms roll in. You would no longer live within an atmosphere. You would live beneath one, constructed and conditional. Even a single failure could turn fatal. A cracked valve, a clogged filter, a pressure drop, and the invisible economy of life collapses. The margin between living and suffocating is measured not in minutes, but in machine cycles. The colonists would move through their domes, aware that every breath depends on a chain of systems they cannot see, but must always trust. Maintenance would become ritual. Air would become sacred. Over time, oxygen itself might become a form of currency, a literal measure of worth and work. Air credits traded for labor, power, or food. A system where the price of a mistake could be calculated in breaths remaining. It sounds dystopian, but it's only practical in an environment where nothing comes free. Life support would no longer be metaphorical, it would be the economy itself. And yet, there is beauty in that fragility. To know the cost of each breath is to understand its value. On Earth, we waste air on noise and haste. On Mars, every inhalation would be an act of gratitude. Each breath would carry awareness, of distance, of effort, of dependence. To live on Mars would mean rediscovering what life really costs, stripped of illusion, but it would also mean learning to appreciate what we have always taken for granted. The atmosphere that cradles Earth, the oxygen made by forests and oceans, the silent exchange between breath and leaf. Mars reminds us that air itself is the most precious resource in the universe, not because it is rare, but because it is fragile. To breathe freely is to live within a miracle so ordinary we forget it's there. On Mars, we would remember. Every inhale would be a prayer whispered to the machines that keep us alive, and to the home world that still breathes for free. We imagine humanity conquering Mars, but survival here isn't victory, it's endurance. There is no thriving, only delaying death long enough to call it a mission. From the safety of Earth, Mars looks like a challenge waiting to be overcome. We picture shining domes on the red plains, explorers standing proudly against the horizon, humanity expanding into the stars. The idea is romantic, heroic, even. But beneath that dream lies a colder truth. On Mars, the goal is not to live well, but simply to keep living. The fantasy of colonization dissolves quickly into the mathematics of survival. Every aspect of existence on Mars is an equation with no room for error. Air, water, food, heat. Each must be manufactured and maintained with unbroken precision. Every system that sustains life depends on another, and every one of them can fail. The chain of survival is fragile, and the planet offers no mercy. If power falters, air thins. If a seal cracks, pressure drops. If a single valve sticks in the wrong position, the atmosphere outside, so silent, so calm, rushes in like an invisible predator. There is no redundancy built by nature here. On Earth, we are buffered by abundance. Oxygen replenishes, rain falls, sunlight returns each morning. On Mars, nothing renews itself. Every resource has an expiration date, and every moment of life must be earned. Even sleep carries risk, as the hum of machinery continues to guard against the void. It is not a place where humanity will live. It is a place where humanity will endure. And endurance is not the same as thriving. In the best-case scenario, colonists would exist within sealed environments, surrounded by machines that simulate the comfort of home, but never quite achieve it. The air would taste faintly of metal, the water recycled endlessly, the light artificial. There would be no weather, no scent of soil, no natural sky. Every sensation would remind them that this world does not belong to them. Psychologically, the illusion of progress would erode. The first settlers might call themselves pioneers. The next generations might call themselves prisoners. The promise of expansion, of freedom among the stars, would fade beneath the weight of constant vigilance. Living on Mars would not feel like conquering a new frontier. It would feel like maintaining a fragile bubble against extinction. Even the milestones, building habitats, growing crops, producing water, would not bring comfort, only more complexity. Each solution breeds another dependency, another system to monitor. Progress becomes a loop, work to survive so you can keep working. It's a kind of purgatory dressed in the language of exploration. But perhaps that is the paradox of Mars. It reveals not the limits of technology, but the limits of ambition. Humanity may reach the red planet, plant its flag, and call it colonization. Yet every breath, every calorie, every heartbeat will still depend on Earth. True independence will remain a mirage shimmering in the thin Martian light. Mars doesn't care about our ideals of conquest or destiny. It offers no comfort, no collaboration. It simply watches as we test ourselves against its indifference. And in that indifference lies its truth. Survival here is not triumph. It's temporary. A constant deferral of the inevitable. To live on Mars is to accept a quiet bargain. You will never win against the planet. You will only postpone its victory. And yet, perhaps that, too, is what makes the dream so human. We are a species that finds meaning not in comfort, but in struggle. Even when survival itself is an illusion, we chase it anyway, because hope, however fragile, is the one resource that no world can strip away. A Martian day is only slightly longer than ours, but the years stretch twice as long. Seasons last forever. Time flows differently here, and the human psyche, calibrated for Earth, loses its rhythm. On paper, it sounds simple. A day on Mars lasts 24 hours and 39 minutes. Hardly a difference at all. But the subtleties of time become profound when they shape the body, the mind, and the cycle of life itself. Our circadian rhythm, the internal metronome that governs sleep, metabolism, and emotion, is tuned to the precise pace of Earth's rotation. Every heartbeat, every hormone pulse, every flicker of fatigue follows that 24-hour drumbeat. On Mars, that extra 39 minutes stretches the rhythm out of sync, slowly, invisibly, until the body no longer knows when to wake or rest. For short missions, astronauts can adapt with scheduled lighting, artificial dawns and dusks carefully timed to trick the brain. But for long-term colonists, time itself begins to feel distorted. Days drift, nights lengthen, the line between one and the next blurs. Sleep becomes irregular, dreams restless. The human mind, deprived of the subtle cues that Earth provides, the pull of gravity, the tilt of daylight, the scent of changing air, loses its natural calibration. Time becomes not a rhythm, but a fog. And then there are the years. Mars orbits farther from the Sun, taking 687 Earth days to complete a single revolution. A Martian year lasts nearly 2 of ours, which means its seasons linger like memories that refuse to fade. Winter grips the planet for months on end. Summer, though mild, stretches endlessly without the relief of rain or renewal. The passage of time feels exaggerated, each season a vast chapter of monotony. For the first colonists, the calendar would fracture. Birthdays would fall out of step. Holidays would lose meaning. The shared cadence of humanity would dissolve beneath the alien calendar of a silent world. Even the sun itself contributes to the illusion. On Mars, daylight is weaker, only 43% as bright as on Earth. Shadows are longer, light more diffuse, sunsets lingering in hazy, rust-colored glow. Time feels slower when the sun never quite burns or fades. The sky shifts from peach to violet, but the difference is subtle, almost imperceptible. There is no dawn chorus of birds, no sound to mark the turning of hours. The silence stretches, and the mind fills it with its own inventions. For those living in isolation, this distortion could become psychological gravity. Without the grounding rhythm of day and night, emotion itself begins to flatten. Motivation fades, energy wanes, memory loops. Astronauts on long missions already experience temporal drift, a sensation that days repeat, blending into one endless, colorless cycle. On Mars, That drift could become the default state of mind. And yet, perhaps the strangest effect of all is how time stretches emotionally. Distance delays communication with Earth by minutes, but it feels like hours. The wait for news, for signals, for supply ships measured in months, each moment expands. To live on Mars is to exist out of sync, not just with a planet, but with humanity itself. You are both present and forgotten, a heartbeat lagging behind the rest of your species. Some might find beauty in this altered flow. Time on Mars could feel meditative, unhurried, a slower clock that invites reflection. A civilization there might evolve its own rhythm, one detached from the frantic tempo of Earth. But before that serenity can emerge, there will be struggle. For the first generations, time itself will feel like an enemy, stretching every day into silence, every year into endurance. Mars does not just test our technology, it tests our patience. To live here is to learn to breathe slower, to think longer, to move with the rhythm of a planet that has never known haste. On Mars, time does not flow forward. It lingers, cold, patient, eternal, and waits for us to adjust. Martian sunsets are blue, not red. The dust scatters light differently, turning evening skies into ghostly azure. It's beautiful and deeply alien. A reminder that beauty doesn't mean belonging. Every world has its own kind of twilight, its own moment when light meets shadow and day exhales into night. On Earth, sunsets are fire and gold, painted by the thick air that bends sunlight into warmth. But on Mars, the opposite happens. As the sun sinks beneath the horizon, the red planet turns blue. The dust, those fine, iron-rich grains that coat the planet, scatters light backward instead of forward. Where our skies glow crimson, Mars glows sapphire. For a few fleeting minutes, the world that is red by day becomes blue by dusk, as though it briefly remembers a time when oceans might have reflected its light. It is a haunting inversion of what we know. The red planet wears the color of Earth's sky only as the light fades, as if mocking our sense of familiarity. The blue is not the color of air or water, it's the color of scattering in a vacuum, of light fighting its way through thinness and dust. It's beautiful, but it's also wrong. The hue stirs recognition and unease at once, a reminder that nature's poetry is not bound to comfort. Standing there, watching that distant sun shrink to half the size it appears from Earth, you would feel the scale of separation more profoundly than ever before. The horizon stretches wider, the shadows longer. The sun's warmth, already faint during the day, feels like memory by the time it sets. The blue glow lingers like a dream dissolving in slow motion, painting the sky with a color that feels alive but unwelcoming. There's no chorus of insects, no softening breeze, no hum of life as the world cools, only silence and the soft sigh of dust shifting under an alien twilight. Astronauts who have seen Martian sunsets describe them as still, almost sacred. The atmosphere is so thin that the transition between day and night happens quickly. Within minutes, the light collapses into darkness. No twilight hour, no gentle fade, only a sudden descent into cold. The stars emerge almost instantly, sharp and brilliant, as though the universe wastes no time here. The sun's last light reflects off the horizon like a whisper that never returns. For colonists, that daily event would become ritual. The sight of a blue sunset on a red world, a beauty that doesn't comfort but confronts. It would remind them that they live beneath a sky not meant for them, under a sun that gives too little and takes too long to rise again. They would watch it every evening, not for peace, but for perspective, for proof that even in the most hostile places, beauty persists. And perhaps, in time, they would learn something profound from it. That belonging isn't always about comfort or warmth or familiarity. Sometimes it's about recognition, the moment you see something utterly alien and still feel awe instead of fear. Mars offers that in abundance, beauty without welcome, wonder without kindness. When night finally falls, the blue fades to black and the stars take over the sky, billions of them, sharp against the void. The sun that once nurtured life now feels like a distant ember, and in that fading light, one truth settles quietly in the dust. Beauty can exist anywhere, but not every beauty was meant for us. Every mission, every rover, every simulation whispers the same equation: cost versus survival. For each kilogram of cargo, 1,000 decisions. For every colonist, 1,000,000 risks. Space exploration has always been a balance between numbers and dreams. On paper, Mars exists as a spreadsheet. Columns of delta-V calculations, oxygen ratios, power budgets, and payload masses. Every breath, every calorie, every gram of water must be quantified, measured, and justified. Even hope has a weight here, and it must fit within the launch capacity of a rocket. The poetry of discovery is written in the language of mathematics. To send a single human to Mars is to carry the cost of an ecosystem. Life is heavy: oxygen generators, radiation shielding, water recyclers, hydroponic gardens, pressurized habitats. Each kilogram launched from Earth demands more fuel, more energy, more logistics. And every added kilogram increases the cost exponentially. A single screw, a few millimeters of wire, a backup system, all are decisions made at the intersection of physics and possibility. The problem compounds when scaled to survival. A colony of even a few dozen people would require hundreds of tons of supplies and infrastructure, most of which cannot yet be built there. We cannot grow food without soil, air, and light. We cannot build without materials we have not yet learned to mine. Every mission depends on the one before it, and failure in any stage echoes through the future. The cost isn't just financial, it's temporal. Every mistake wastes years, perhaps decades, of progress. In this way, Mars becomes an equation of diminishing returns. The more we send, the harder it becomes to send more. The farther we reach, the more fragile our reach appears. Engineers calculate not just trajectories but lifespans: how long the oxygen will last, how fast the solar panels will degrade, how much energy the heaters will consume in winter. The numbers are unforgiving, but they are also the scaffolding of our ambition. And yet, within this labyrinth of math lies something deeply human: the refusal to stop calculating. Every rover that lands, every satellite that maps, every simulation that runs is an act of faith disguised as science. Hope itself becomes measurable, expressed in data packets and equations. Consider the rovers that paved the path: Spirit, Opportunity, Curiosity, Perseverance. Each one was built with the understanding that it would likely fail, and yet each exceeded expectation. Opportunity was meant to last 90 days. It lived nearly 15 years. In that overperformance lies a lesson. Numbers can predict limits, but not resilience. Humanity, too, has always found a way to stretch its equations beyond reason. The mathematics of hope is not just about calculation, it's about defiance. It's the moment an engineer adds a safety margin, not because it's required, but because they believe it might make the difference. It's the unspoken acknowledgement that we are not rational creatures alone. We are dreamers armed with formulas. And so, for every kilogram we send, for every variable we solve, Mars quietly reminds us of the equation we can't yet balance, the one between survival and meaning. We can measure the cost of life, but not its worth. Hope, after all, is the one quantity that refuses to stay confined to the math. It's the unknown variable that turns numbers into destiny. And on Mars, that equation, cost versus survival, will never truly be solved. It will only be lived. Before humans ever walk there, Mars will already be covered in our remains, robots frozen in dust, their solar panels buried. Our first colonists will be machines, our ghosts of ambition. Even now, Mars is not empty. It is a graveyard of our curiosity, a planet scattered with the quiet relics of exploration. Rovers, landers, parachutes, descent stages, All lie still beneath the endless red horizon, half buried in the dust that never stops moving. From orbit, they are barely visible, tiny marks on a world that dwarfs them utterly. But up close, they are monuments. Silent, stoic, patient. The first footprints on Mars are not made by humans, but by wheels and struts, each one a declaration that we once reached this far. The Viking landers came first in the 1970s, their instruments long silent, their circuitry corroded by time. Then came Spirit and Opportunity, twins born of the same dream, sent to wander and learn, to taste the soil, to listen to the wind. Spirit grew trapped in sand, one wheel grinding uselessly until its solar panels dimmed forever. Opportunity endured longer, surviving 15 years of storms and solitude before a planet-wide dust storm finally smothered it. Its last message was simple, almost human. My battery is low, and it's getting dark. Scattered farther across the planet are the remains of Phoenix, Insight, Sojourner, Curiosity's discarded landing gear, and the still active Perseverance, humming softly on borrowed time. Each machine carries a story, a fragment of human persistence. They are explorers, yes, but also ancestors, paving the way for others who may one day follow. They represent not colonization, but conversation, a dialogue between our ingenuity and a world that answers only in silence. The Martian wind does not mourn them. It moves slowly, carrying dust grain by grain, burying what we left behind. Over decades, our machines will fade from view, their solar panels coated, their metal worn thin by radiation. The planet will reclaim them in its patient way, turning them into fossils of technology, a kind of archaeological layer marking the first contact between life and a dead world. Future astronauts might one day find them, preserved like relics of a distant age. They may brush away the dust from a rover's camera eye, staring into the same lens that once stared at alien sunsets. They might walk past discarded heat shields, faded parachutes fluttering like ghosts in the thin breeze. In those moments, they will not just see machines, they will see mirrors, proof that humanity's first steps on Mars were made through proxies, fragile bodies of steel and silicon that carried our courage across millions of kilometers. There is something profoundly poetic about that. Long before we ever risked our own breath, we sent mechanical scouts to test the air for us, to taste, to touch, to die in our place. Each one was a promise that we would someday follow, that the red planet would not remain untouched forever. And when humans finally arrive, they will not be the first settlers, but the inheritors of a legacy written in dust and circuitry. Perhaps that is how all exploration begins, not with conquest, but with sacrifice. The bones of robots scattered across Mars are not failures. They are the first chapter of endurance. They remind us that discovery is not measured in years of success, but in the quiet persistence of those that fall silent so that others may speak. And someday, when the first colony looks out over the horizon, they may see not a barren world, but a graveyard of dreams, and in it, the reflection of their own. It was waiting, patiently, for us to arrive and meet the ghosts we left there. Every obstacle Mars presents teaches us something about ourselves, how fragile we are, how temporary. In studying its silence, we learn the physics of humility. Every attempt to reach Mars has begun with confidence, and ended, more often than not, in loss. More than half the missions ever sent there have failed. Rockets veered off course, parachutes tore, landers crashed, signals vanished into static. It is not carelessness that undoes us, it is the complexity of the void. Mars demands perfection in a universe that allows none. And yet, every failure adds to our understanding, piece by painful piece. The first robotic explorers taught us how fragile engineering becomes beyond Earth's cradle. The vacuum, the cold, the radiation, all conspire against human ambition. Circuits freeze, seals crack. Solar panels lose their strength beneath layers of dust finer than smoke. But instead of retreating, we learn. Each failure is dissected, studied, reborn into the next generation of exploration. We crash, we rebuild, we send again. In this repetition lies the quiet rhythm of progress, the heartbeat of curiosity that refuses to stop. Mars humbles us because it reminds us how small we are in the hierarchy of nature. On Earth, we bend the world to our will, we move mountains, build cities, control rivers. But on Mars, the smallest gust of wind, the tiniest grain of dust, the faintest deviation in temperature can erase years of effort. The planet doesn't resist us out of malice, it simply doesn't notice us. In its indifference, we rediscover something we've long forgotten, that existence itself is precarious, that success is not guaranteed, that survival is not a right but a privilege. Each failed mission leaves behind a silent monument, a lesson written in wreckage. The Mars Climate Orbiter burned in the atmosphere because one team calculated thrust in pounds, while another used newtons. The Beagle 2 lander unfolded incompletely, its panels jamming before it could phone home. Schiaparelli fell too fast, its sensors blinded by software error. Each of these mistakes was human, not in the sense of error, but in the sense of persistence. We fail because we try, and each failure pushes us closer to understanding. Failure is not just technological, it's emotional. It teaches us patience, and more importantly, perspective. To explore Mars is to confront time on a cosmic scale. Our missions last years, but Mars measures change in millennia. The universe does not hurry, and Mars teaches us to slow down, to listen, to observe. And perhaps that is the deeper gift hidden in the frustration of failure. Each broken lander, each lost signal, each forgotten machine becomes part of a greater experiment, one not about success, but about endurance. Every time we fail and return, we rewrite what it means to be human. Because Mars is not a goal to be achieved, it is a teacher. Its silence, its resistance, its distance, they strip us of arrogance and leave behind something purer, curiosity without entitlement. We don't conquer the red planet, we learn to coexist with it, to respect its permanence. In its quiet, Mars tells us what all great teachers do, that the lesson was never about victory, but about awareness, that to reach for the impossible is to accept imperfection, and that even in failure there is progress, because in every setback we are reminded that the universe owes us nothing. Yet we still reach for it anyway. Mars is not an escape, it's a reflection. The more we try to build a new world there, the more we see what we've lost here. Colonizing Mars begins to feel like trying to rebuild a home we've already abandoned. For centuries, we have looked toward the night sky, not only with curiosity, but with longing. Mars, that small red star wandering through the constellations, became a symbol of possibility, a new beginning waiting just beyond reach. But now, as our machines draw maps of its deserts and our scientists dream of its domes, a quiet truth emerges. Mars is not the future we seek. Everything we plan to build there, the habitats, the greenhouses, the air recyclers, the artificial skies, are recreations of what Earth already gives freely. Oxygen, water, warmth, gravity, and food all must be simulated, sustained by endless energy and vigilance. Each breath on Mars would remind us that on Earth, life is effortless. Each artificial garden would remind us that once we had forests that grew without our permission. The very act of survival there would feel like an apology for forgetting what made our own planet miraculous. And yet, that shadow runs deeper. Mars holds up a mirror to humanity itself. It reflects our tendency to escape rather than heal, to look outward when we fear looking inward. The red planet seduces us with its silence, a place untouched by pollution, greed, or history. But that blankness is not purity, it is emptiness. To settle Mars without understanding Earth is to repeat the same mistakes under a different sky. The same divisions, the same hunger for expansion, the same neglect of balance. A new world cannot save us from ourselves if we bring the old one with us. Imagine the first colonists gazing at Earth through the faint blue shimmer of the Martian sky. A single glowing dot, all oceans and memory. They would see not a home to return to, but a ghost. Communication delays, months of distance, years of separation. Earth would become mythology. Its clouds, its trees, its sounds of life would fade from memory, replaced by mechanical hums and recycled air. The planet we once called home would become the dream, and Mars the fragile imitation. In that way, Mars is less an escape and more a lesson. It shows us the fragility of habitability, the razor-thin line that allows life to thrive. It reminds us that paradise is not the norm of the universe, but the rarest anomaly. We live in the only known world where life can walk unguarded beneath a sky. To abandon that miracle in search of another is not courage, it is amnesia. But perhaps this reflection is exactly what we need. Mars, barren and silent, forces us to see the cost of neglect. It reminds us that no matter how advanced our machines become, no matter how many rockets we launch, there is no substitute for a living world. No engineering can replicate the hum of rain, the weight of wind, the scent of soil after a storm. Colonizing Mars will not save humanity, but it might teach us to appreciate what we have left behind, to value the delicate balance of the only world that has ever loved us back. The red planet is not our refuge, it is our reminder, because when we gaze into the silence of Mars, what we truly see is the shadow of Earth, fading, fragile, and still waiting for us to remember how to care for it. If life ever existed here, it is now dust. Microbial fossils may sleep beneath the soil, frozen in place for eons. Mars once breathed. Now, it waits for us to listen. Long before our machines arrived, Mars may have been alive, or at least alive enough to imagine the possibility. Billions of years ago, its surface bore the fingerprints of water, riverbeds carved into stone, delta fans spreading into ancient lakes, minerals formed only in the presence of liquid. There were clouds then, rain perhaps, and an atmosphere thick enough to hold warmth. For a brief cosmic moment, Mars was temperate, fertile, awake. The planet exhaled, and something, perhaps simple, microscopic, fragile, might have stirred in the shallow light of an alien dawn. But somewhere along the timeline of eternity, the breath stopped, its magnetic field faded, its atmosphere thinned, and the warmth fled. The water froze or vanished into space. Whatever life may have taken root was sealed away beneath rock and ice, preserved like memory in permafrost. Mars fell asleep, not in violence, but in slow surrender. A planet that once might have sung with chemical motion went silent, one atom at a time. And yet, the silence is not empty, it hums with potential. Beneath the dust and radiation, buried meters below the surface, there may still be traces of what once was. Fossilized microbes, dormant spores, or molecular fossils, echoes of biochemistry waiting for discovery. Every rover's drill, every sensor's hum, is a question whispered into that stillness. Scientists chase those whispers with reverence. Each scoop of regolith, each mineral sample, is a message from a time, before Earth had oceans or breath of its own. If life did begin on Mars, it may have predated ours. Some theories even suggest that we are its descendants, that the building blocks of life were carried from Mars to Earth on ancient meteorites, cosmic seeds flung across space. If that's true, then we are not visitors at all. We are the children of a planet that died so that another could live. It's a haunting thought that our origins may lie in a world that could not sustain us, and that in reaching back toward it, we are searching for the beginning of ourselves. In that way, Mars is not just a planet, it is a mirror of memory. The remnants of its life, if found, would be more than fossils. They would be proof that the universe is capable of repetition, that life, given even the smallest chance, will always try again. Standing on the surface, under a pale sun and a rust-colored sky, you might feel that ancient breath still lingering in the cold air. The dust beneath your boots once flowed as rivers. The rocks around you once sat beneath clouds. Every gust of wind is a whisper from that time, carrying the faint sigh of a world that remembers. Mars once breathed, and though the breath is gone, the echo remains. We listen through our machines, our missions, our endless questions, hoping to catch even the faintest exhalation of a life that once was. And perhaps, one day, when we finally uncover proof, a single cell, a trace of carbon chain, a fossilized pattern etched in stone, we will realize what Mars has been trying to tell us all along. That life is not a miracle unique to Earth, but a tendency of the universe itself. That even in silence, the cosmos is speaking. And that every breath, even the last one of a planet, becomes part of a much greater conversation, one that never truly ends. Dreams of Mars colonies fill science fiction and policy papers alike, but the physics remains stubborn. The human body, atmosphere, and psyche all rebel against the red planet. Dreams are cheap, rockets are not. For over a century, Mars has existed as a canvas for human imagination. Writers and visionaries have painted it with hope and conquest, with domed cities glowing under alien skies, with explorers building new societies among the dunes. It is the archetype of tomorrow, the symbol of humanity's next great step. But the more we learn, the further that dream drifts from reality. The red planet that once seemed a second home reveals itself, piece by piece, as a place that will never truly want us. The obstacles are not poetic, they're physical, mathematical, merciless. The radiation alone is enough to halve a human lifespan. The air is poison, the gravity too weak, the cold too deep, the dust too fine. Each of these challenges is solvable, perhaps in isolation, but together they form an equation that does not balance. Every solution adds weight, cost, and complexity. Every innovation breeds 10 new dependencies. To build a city on Mars is to build 1,000 fragile systems and hope that none of them fail. Even getting there remains an act of extraordinary expense. Launch windows open once every 26 months. Each journey takes 6 to 9 months, costing billions. Every extra kilogram of cargo is another ton of fuel. A self-sustaining colony would require thousands of launches and decades of infrastructure. For now, the economics of Mars remain fantasy. Rockets can deliver supplies, but not salvation. And yet, humanity dreams on. We sketch blueprints for domes and power plants, design pressurized suits and AI maintenance bots, write treaties for worlds that no one yet inhabits. Politicians speak of Mars as the next frontier. Billionaires promise settlements by mid-century, and children grow up believing they might one day walk there. The mythology persists because it comforts us. Mars represents continuity, a story where our species never stops reaching, never stops becoming. But between inspiration and execution stands the hard gravity of truth. For all our progress, we remain a species bound to one planet. Every breath, every heartbeat, every emotion evolved for Earth's pressure, Earth's magnetism, Earth's rhythm. To live elsewhere means to simulate what we already have, and simulation is never perfect. Even if we build a city beneath the surface, shielded from radiation, powered by reactors, sustained by hydroponics, it would still be an island of borrowed life. A single power failure, a single miscalculation, could unravel everything. In this light, the dream of colonizing Mars begins to resemble an act of self-deception. Less about expansion, more about escape. We imagine leaving behind our mistakes, our pollution, our wars, as though distance could dissolve consequence. But Mars offers no absolution. Its desolation is not a blank page, it is a warning written in stone. And perhaps that's why the dream persists, because it forces us to confront what we take for granted. In chasing Mars, we are reminded of how extraordinary Earth truly is. We design artificial skies only to realize how perfect our real one already was. We calculate how to recycle air and water only to remember how carelessly we once wasted them. The future we imagine on Mars may never come. But maybe that's not failure. It's purpose. The pursuit itself teaches us something sacred, that life is rare, balance is delicate, and paradise cannot be rebuilt by leaving it behind. Mars humbles us not by what it withholds, but by what it reflects, a mirror showing how much we already have and how easily it could be lost. The dream of living there may forever remain just that, a dream. But perhaps that's exactly what we need. A distant vision that reminds us that the most habitable planet we'll ever know is the one already beneath our feet. Perhaps Mars was never meant to be home, but a teacher. Since the first telescopes revealed its rusty glow, Mars has drawn our gaze like a promise. We projected onto it everything we wanted to believe about ourselves, that we were explorers, survivors, conquerors of nature. Each rover that touched its soil, each mission that traced its orbit, was an echo of that ancient drive to go farther. Yet as our understanding deepened, the planet's truth grew clearer. Mars does not need us. It exists in sublime indifference, neither inviting nor forbidding, a silent reminder of the universe's scale. It is easy to mistake ambition for destiny. Humanity's story is one of movement, across oceans, across continents, and now, across the void. But the cosmos is not an empty field waiting for us to fill it. It is a mirror, and when we look into it, we see not the stars, but ourselves. Mars, more than any other world, reflects that duality. In its red deserts and quiet valleys, we see the outlines of both our courage and our arrogance. Our machines crawl its surface, gathering data, drilling samples, tracing the memory of rivers long gone. Every discovery humbles us. The ancient lakebeds whisper of climates that changed, atmospheres that vanished, and worlds that could not hold on to life. In those patterns, we recognize a warning, the same fragility that shadows our own planet. If Mars teaches us anything, it's that habitability is not a permanent state. It's a fleeting balance, one that even entire worlds can lose. Perhaps that's why we are drawn to it. On some level, we know that Mars is not a destination, but a reflection of what could happen if we forget how to care for home. The thin air, the frozen ground, the silence. They are not barriers to conquest, but messages in another language. The planet speaks through absence, reminding us that nature does not promise warmth, that survival is not the default condition of existence. In trying to colonize Mars, we are not just testing technology, we are testing identity. We're asking whether our drive to expand is born of curiosity or fear, whether exploration is still about wonder or about escape. Every plan to build a city on Mars is also an admission that we might be failing the one we already have. The red planet forces us to confront the shadow of ambition, that we often chase new horizons not because they are better, but because we have broken the old ones. Yet, there is no shame in ambition itself. Mars is not mocking us, it is guiding us. It challenges us to dream responsibly, to innovate without illusion, to balance our hunger for progress with gratitude for what sustains us. It asks us to understand that exploration need not mean abandonment, and that to stay, to nurture, to preserve, can be as heroic as to go. When we finally accept Mars for what it is, not a home, but a lesson, we might come to see the true meaning of our reach. The purpose of looking outward is not to escape, but to return with greater reverence for what we already have. In the end, Mars is not a destination, but a mirror. And in that reflection, we glimpse the truth that has always followed us through the cosmos. That the most profound frontier was never out there. It was within us all along. In the end, Mars doesn't refuse us. It simply waits, indifferent. Its deserts whisper a single truth across the void, that not all worlds are meant to be tamed. Some exist to remind us of the rare gift of Earth. After all the calculations, the missions, the dreams of domes beneath alien suns, what remains is silence. A silence that hums through the dust, seeps through the rocks, and stretches across the years between planets. Mars doesn't rage against our presence or guard its secrets with hostility. It simply exists, timeless and still, a patient witness to our ambition. In that stillness lies something profound, a truth that speaks louder than any discovery we could make. For all our attempts to shape the universe in our image, some places resist becoming human stories. Mars is one of them. It is not an enemy to be conquered or a paradise waiting to bloom. It is a world content in its solitude. Its landscapes are older than memory, sculpted by wind and time alone. Every crater, every canyon, every mountain stands as a monument to the eons before we arrived and to the eons that will follow after we are gone. Walk across its surface, and you would feel that eternity pressing against you. The ground beneath your boots has not changed in billions of years. The air, thin and sharp, carries no echo but your own. There are no insects, no rustle of leaves, no water flowing beneath your feet. Only the soft whisper of dust shifting in the cold and the distant hum of your own machinery, your only heartbeat in a dead world. And yet, the silence is not empty. It is eloquent. It speaks of balance, of patience, of endurance, without need for growth or motion. It tells us that not all meaning requires life, that beauty can exist without purpose. It does not dream, and in that lack of desire lies its strange perfection. Perhaps that is the final lesson it offers, that not every world is meant to serve us, and not every silence needs to be filled. Mars teaches through indifference, the kind that humbles rather than harms. It asks nothing of us but acknowledgement, and in return, it shows us the miracle of what we already have. Because compared to its stillness, Earth is noise and warmth and motion, a miracle of imbalance that somehow sustains life. When we look at Mars, we are not gazing into the future, but into contrast. Its silence defines our sound. Its stillness defines our movement. Its emptiness defines our abundance. In the cold reflection of its deserts, we see the fragility of our own existence, the fine thread of atmosphere, temperature, and chemistry that separates paradise from desolation. Mars does not need our presence to be meaningful. It was complete long before we arrived, and perhaps that is the message carried through the silence, that the universe does not revolve around our survival, but that our awareness of it, the act of wonder itself, is what gives our lives meaning. So, as we listen to that silence echoing across the void, let it remind us not of conquest, but of gratitude, not of escape, but of belonging. Because Mars, in all its still, indifferent beauty, is not a destination. It's a mirror reflecting the fragile, extraordinary grace of the world we already call home. The red planet fades behind us now, shrinking once more to a distant ember in the velvet dark. We came here searching for a second Earth, but what we found was a mirror, a reminder of how rare home truly is. Mars showed us the silence that follows when a world loses its breath. It taught us the weight of atmosphere, the patience of ice, the loneliness of distance, and the delicate balance that keeps our own blue world alive. We saw how gravity sculpts the body, how radiation erases memory, how even the most advanced machines struggle against time. But in every harsh truth, there was beauty too, the fragile persistence of light, the poetry of dust shaped by wind, the quiet promise that the universe, though cold, is still full of meaning. Perhaps that is the lesson Mars wanted to give us, that not every frontier must be conquered. That wonder is its own form of belonging. That Earth, so warm, so loud, so alive, is already a miracle worth protecting. So tonight, as you drift towards sleep, let that thought stay with you. That somewhere in the darkness, Mars still turns, silent, ancient, and patient, and from across the void, it reminds us to care for the only planet that knows our name. Rest now, traveler. The stars are watching. And for this brief moment in cosmic time, you are home.